ಎಲ್ಲ ಅನುಷ ಮೇಡಮ್ ಎಸ್ಕೇಪ್ ಆಗ್ಬಿಟ್ಟಾರ.
ಫೋನ್ ಎತ್ತಲ್ಲ ಸರ್?
ಇಲ್ಲ ಹೇಳಿದ್ದೆ 10 ಗಂಟೆಗೆ ಲಾಗಿನ್ ಆಗಿಲ್ಲ. ನೋಡೋಣ ತಡ್ರಿ 10:30 10 ಕಾಲ. ಈಗ ನೋಡ್ರಿ ಸರ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಬರ್ತಾ ಆಯ್ತಾ?
ಸರ್ ನೋಡಿ. ಸರ್ ಲಿಂಕ್ ಇನ್ನೊಂದ್ಸಲ ಕಳಿಸಿ ಸರ್.
ಕಳ್ಸಿದ್ದೇನೆ ಸರ್ ಯೂಟ್ಯೂಬ್ದು ಕೆಳಗಡೆ.
ಕಳಿಸಿದೆ ಬಟ್ ಇದು ಆಗ್ತಿಲ್ಲ ಸರ್, ಅದು
ಏನಾಗ್ತಿಲ್ಲ?
ಸೆಲೆಕ್ಟ್ ಆಗ್ತಿಲ್ಲ.
ಯಾಕೆ?
ಅದು ಕ್ಲಿಕ್ ಆಗ್ತಾ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಅಲ್ಲಿ ಇದಕ್ಕೆ ಹೋಗ್ತದೆ ಸರ್, ಲಿಂಕ್ ಆ ತರ ಬಂದಿಲ್ಲ ಅದು.
ಅಂದ್ರೆ
ನಾವು ಅದ್ರ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡಿದ ತಕ್ಷಣ ಅಲ್ಲಿಗೆ ಹೋಗುತ್ತಲ್ಲ ಸರ್, ಆ ತರ ಹೈಲೈಟ್ ಆಗಿಲ್ಲ ಅದು, ಸುಮ್ಮನೆ ಹಂಗೆ ಟೆಕ್ಸ್ಟ್ ಮೆಸೇಜ್ ತರ ಬಂದಿದೆ.
ಈಗ ನೋಡ್ರಿ.
ಹಾ ಇವಾಗ ಬಂತು.
ಈಗ ಒಂದ್ ಕೆಲಸ ಮಾಡ್ರಿ ಸರ್.
ಹಾ ಸರ್.
ಈಗ ಇನ್ನೊಂದು ಮೊಬೈಲ್ ತಗೊಂಡ್ಬಿಟ್ಟು
ಹಾ ಸರ್.
ನೀವು ಇದ್ರಲ್ಲಿ ಮಾತಾಡ್ರಿ ಗೂಗಲ್ ಮೀಟ್ ಅಲ್ಲಿ. ಅದ್ರಲ್ಲಿ ವಿಸಿಬಿಲಿಟಿ ಐತಿಲ್ಲ ಅಂತ ಕೇಳ್ರಿ ನಿಮ್ಮ ಮನೆಯವ್ರಿಗೆ ಯಾವ್ಯಾರ.
ಹಾ ಸರ್ ಕೇಳ್ತೇನೆ.
ಮಾಡಿ ನಮ್ಮ ಮೊಬೈಲ್. ಹಲೋ ಮೇಡಮ್. ಹಾ ಮೇಡಮ್. ಹಾ ಗೂಗಲ್ ಮೀಟ್ ಅಲ್ಲಿ ಆಗ್ಬಿಟ್ರಿ, ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಆಗ್ರಿ. ವಾಟ್ಸಪ್ ಕಳ್ಸಿದ್ರೆ ನೋಡ್ರಿ ರಿಸಲ್ಟ್. ಅದು ನೋಡ್ರಿ ಬರುತ್ತೆ. ಶ್ರೀಕಾಂತ್ ಸರ್.
ಹೇಳಿ ಸರ್.
ಏನ್ ಸರ್ ಏನಾಯ್ತು ನೋಡ್ತಿದ್ದೀರಾ?
ಹಾ ಸರ್ ನೋಡ್ತಾ ಇದ್ದೀನಿ ಸರ್, ಲೋಡ್ ಆಗ್ತಾ ಇದೆ. ವಿಡಿಯೋ ಅನ್ಅವೈಲಬಲ್ ಅಂತ ಬರ್ತಿದೆ ಸರ್. ಏನ್ ಮಾಡಿರಿ ಸರ್ ಈಗ ನಾವು ಯೂಟ್ಯೂಬ್?
ಏನ್ ಸರ್?
ಯೂಟ್ಯೂಬ್ ಆನ್ ಇದೆನಾ ಸರ್?
ಯೂಟ್ಯೂಬ್ ಆನ್ ಐತೆ ಸರ್, ಬಟ್ ಪ್ರೈವೇಟ್ ಕೊಟ್ಟಿದ್ದೆ ಅಷ್ಟೇ ಲಿಂಕ್.
ಹೌದಾ, ವಿಡಿಯೋ ಅನ್ಅವೈಲಬಲ್ ಅಂತ ಬರ್ತಿದೆ.
ಒಂದು ಸೆಕೆಂಡ್. ಅಲ್ಲ ಮೇಡಮ್. ಹಾಂ ಹೇಳ್ರಿ. ಹೌದಾ, ಒಂದು ಸೆಕೆಂಡ್ ಸರ್. ಅದು ಪಬ್ಲಿಕ್ ಮಾಡ್ಬೇಕು ಅನ್ಸತ್ತೆ ವಿಡಿಯೋ ಅಲ್ವಾ ಶ್ರೀಕಾಂತ್ ಸರ್?
ಹ್ಞೂ ಸರ್ ಪಬ್ಲಿಕ್ ಮಾಡ್ರಿ ಅದನ್ನ. ದಿಸ್ ವಿಡಿಯೋ ಇಸ್ ಪ್ರೈವೇಟ್ ಅಂತ ಹೇಳಿ ಸರ್ ಅದು.
ಈಗ ಚೆಕ್ ಮಾಡ್ರಿ ಸರ್, ಇನ್ನೊಂದು ಲಿಂಕ್ ಕಳಿಸ್ತೀನಿ.
ಹಾ ಸರ್ ಬರ್ತಾ ಇದೆ.
ಸ್ಟ್ರೀಮಿಂಗ್ ಬರ್ತಾ ಇತ್ತಾ?
ಸರ್ ಬರ್ತಾ ಇದೆ ಸರ್. ಏನೋ ಎಡಿಟ್ ಆಪ್ಷನ್ ಏನೋ ಕೊಡ್ತಾ ಇದ್ರಲ್ಲ ಸರ್.
ಬಟ್ ಕಾಣಿಸ್ತಾ ಇತ್ತಲ್ಲ?
ಹಾ ಸರ್ ಕಾಣಿಸ್ತಾ ಇದೆ.
ಹಂಗೆ ಇರಲ್ಲ ಏನಿಲ್ಲ.
ಹಾ ಸರ್ ಮಾಡ್ರಿ ಮಾಡ್ರಿ.
ಅನುಷಾ ಮೇಡಮ್, ಅನುಷಾ ಮೇಡಮ್, ಹಲೋ, ಹಾ ಬರ್ತಾ ಇದೆಯಾ? ಬರ್ತಿದ್ಯಾ? ನಂದು ಶ್ರೀಕಾಂತ್ ಸರ್ ಮಾತಾಡೋದು ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಿದ್ಯಾ ನೋಡ್ರಿ ಅದ್ರಲ್ಲಿ. ಅಲ್ಲ ಸ್ಕ್ರೀನ್ ಶೇರ್ ವಾಯ್ಸ್ ಶ್ರೀಕಾಂತ್ ಸರ್ ಬರ್ತಾ ಇದೆ ನೋಡ್ರಿ. ಶ್ರೀಕಾಂತ್ ಸರ್ ನೀವು ಮಾತಾಡ್ರಿ ಸರ್ ಒಂದು ಸೆಕೆಂಡ್.
ಹಲೋ,
ಹಂಗಲ್ಲ, ಈಗ ಫೋನ್ ಕಟ್ ಮಾಡ್ತಂತೇಳ್ರಿ. ನೀವು ಚೆಕ್ ಮಾಡ್ರಿ. ಶ್ರೀಕಾಂತ್ ಸರ್, ಶ್ರೀಕಾಂತ್ ಸರ್, ಹಲೋ ಶ್ರೀಕಾಂತ್ ಸರ್. ಹಾ ಸರ್, ಮೀಟಿಂಗ್ ಜಾಯ್ನ್ ಆಗಿ ಸರ್, ಹಂಗೆ ಮಾತಾಡ್ರಿ ಒಂದು 2 ನಿಮಿಷ. ಯೂಟ್ಯೂಬಲ್ಲಿ ಅಲ್ಲ, ಗೂಗಲ್ ಮೀಟ್ ಅಲ್ಲ. ಗೂಗಲ್ ಮೀಟಾಗಿ 2 ನಿಮಿಷ ಮಾತಾಡೋಣ. ಸರಿ ಸರ್, ಸರಿ.
ಹಲೋ
ಸರ್. ಹಲೋ ಸರ್.
ಹಾ ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆನಾ?
ಹಾ ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್. ಇದು ನಿಮ್ಮ ವಾಯ್ಸ್ ಈಗ ಅಲ್ಲಿ ಯೂಟ್ಯೂಬಲ್ಲಿ ಬರ್ತಾ ಇದೆ ಸರ್ ಈಗ?
ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡ್ತಿರ್ತಾರೆ ಸರ್.
ಚೆಕ್ ಮಾಡಿ. ನಂದು ನಿಮ್ದು
ಹಾ ಸರ್.
ವಾಯ್ಸ್ ಚೆಕ್ ಮಾಡಿ.
ಹಾ ಸರ್.
ಹಾ ಸರ್, ಕೇಳ್ತಾ ಇತ್ತು ಸರ್ ನಿಮ್ಮ ವಾಯ್ಸ್? ಶ್ರೀಕಾಂತ್ ಸರ್, ಶ್ರೀಕಾಂತ್ ಸರ್,
ಸರ್ ಹೇಳ್ರಿ ಸರ್.
ಕೇಳಿಸ್ತಾ ಇದೆ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ವಾಯ್ಸ್?
ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಕೇಳಿಸ್ತಲ್ಲ ಸರ್ ವಾಯ್ಸ್.
ನಿಮ್ಗೆ ಕೇಳಿಸ್ತಿಲ್ವಾ?
ಬರ್ತಾ ಇಲ್ಲ ಸರ್.
ಏನ್ ಸರ್?
ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಬರ್ತಾ ಇಲ್ಲ ವಾಯ್ಸ್.
ನಂದು ಬರ್ತಿಲ್ವಾ?
ಇವಾಗ ಬರ್ತಾ ಇದೆ ಸರ್. ನಾನ್ ಮಾತಾಡೋದು
ನಿಮ್ದು
ಕೇಳಿಸ್ತಾ ಇದೆ. ನಂದು ಬರ್ತಾ ಇದೆ ಸರ್.
ನಿಮ್ದು ಬರ್ತಾ ಇತ್ತಾ? ಹಲೋ ಮೇಡಮ್.
ಹ್ಞೂ ಸರ್.
ಒಂದು ಸೆಕೆಂಡ್ ಸರ್, ನಾನು ಮಾತಾಡೋದು ಬರ್ತಾ ಇತ್ತಾ ವಾಯ್ಸ್ ಮೇಡಮ್? ಶ್ರೀಕಾಂತ್ ಸರ್ ಬರ್ತಾ ಇತ್ತಾ? ಬಂತಾ? ಕ್ಲಾರಿಟಿ ಇದೆ ಮೇಡಮ್? ವೈಭವ್ ಮತ್ತು ಮಾತಾಡೋದು ಕೇಳಿಸ್ಕೊಟ್ರೆ ಅದು ಇಂಪಾರ್ಟೆಂಟ್. ನಾನು ಮಾತಾಡಂಗಿಲ್ಲ ಅದಕ್ಕೆ. ಗೂಗಲ್ ಮೀಟಲ್ಲಿ ಮಾಡ್ತಿರೋದು ನಾನು ಅದೇ ಮಾಡ್ತಿದ್ದೇನೆ. ನಾನು ವಿಂಡೋ ಶೇರ್ ಮಾಡ್ತಿದ್ದೇನೆ ಯೂಟ್ಯೂಬ್ಗೆ ಅಷ್ಟೇ. ಹೌದಾ, ನಿಮ್ ಗೂಗಲ್ ಮೀಟ್ ನೀವು ಅಷ್ಟೇ ಯೂಸ್ ಮಾಡೋದು? ಇದು ಎಕ್ಸ್ಟ್ರಾ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸಿಗೆ ಅಷ್ಟೇ ಇದೆ, ಔಟ್ ಗೋಯಿಂಗ್ ಅಷ್ಟೇ ಇದೆ. ನೀವು ಗೂಗಲ್ ಮೀಟಲ್ಲೂ ಜಾಯ್ನ್ ಆಗೋದು.
ಹಾಂ ಸರ್, ಬರ್ತಾ ಇದೆ.
ಬರ್ತಾ ಇದೆ ಸರ್?
ಹಾಂ ಸರ್.
ಸರಿ ಮೇಡಮ್, ಓಕೆ ಮೇಡಮ್. 10:30 ಮಾತ್ರ ಚೆಕ್
ಕ್ಲಾರಿಟಿ ಇದೆ ಸರ್.
ಕ್ಲಾರಿಟಿ ಐತ್ರಾ? ಸರಿ.
ಇಲ್ಲ ಸರ್, ಕ್ಲಾರಿಟಿ ಇದೆ.
ಕ್ಲಾರಿಟಿ ಐತಲ್ಲ ಸರ್? ನಿಮ್ದು ವಾಯ್ಸ್ ಬರ್ತಾ ಇತ್ತಲ್ಲ?
ಹಾಂ ಸರ್ ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್. ಇದು ಕಾಣಿಸ್ತಾ ಇದೆ ಅದು.
ಹೌದಾ, ಓಕೆ, ಚೆನ್ನಾಗಿ. ಸರಿ ಸರ್, ಓಕೆ ಸರ್.
ಹಾಂ ಸರ್. ಹಾಂ ಸರ್. ಸರಿ ಸರ್. ಕ್ಲಾರಿಟಿ ಇದೆ ಸರ್. ಇಲ್ಲ ಸರ್, ಕ್ಲಾರಿಟಿ ಇದೆ.
ಕ್ಲಾರಿಟಿ ಐತಲ್ಲ ಸರ್? ನಿಮ್ದು ವಾಯ್ಸ್ ಬರ್ತಾ ಇತ್ತಲ್ಲ?
ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್.
ಅಲ್ಲ ಮೇಡಮ್, ಈಗ ಒಂದು ಲಿಂಕ್ ಕಳಿಸಿದ್ದಾನೆ, ಅದು ಬರ್ತಾ ಶೇರ್ ಆಗ್ತಿದೆ ನೋಡ್ರಿ. ಮೀಟಿಂಗ್ ಗೂಗಲ್ ಮೀಟ್ ಅಲ್ಲಿ ಶರಣ ಸೌಂದರ್ಯ ಯಾರು ಲಾಗಿನ್ ಆಗಿದ್ದಾರೆ ನೋಡ್ರಿ. ಅಲ್ಲ ಮೇಡಮ್, ಅದು ಯೂಟ್ಯೂಬ್ ರೆಕಾರ್ಡಿಂಗ್ ಇರುತ್ತಲ್ಲ, ಹಂಗಾಗಿ ಅದು ಹೋಗುತ್ತೆ. ನಾ ಮಾತಾಡೋದು ಬರ್ತಾ ಇರ್ತೀವಿ. ಇಲ್ಲಿ ಬಿಟ್ಟು ಬಟ್ ಈಗ ಅದು ಯೂಟ್ಯೂಬ್ ಬರ್ತಾ ಇದೆಲ್ಲ, ನಾವೀಗ ಗೂಗಲ್ ಮೀಟ್ ಆನ್ ಮಾಡಿರೋದು. ಓಕೆ, ಬಟ್ ಈಗ ಅದು ಯೂಟ್ಯೂಬ್ ಬರ್ತಾ ಇದೆಲ್ಲ, ನಾವೀಗ ಗೂಗಲ್ ಮೀಟ್ ಆನ್ ಮಾಡಿರೋದು. ಓಕೆ, ನೀವು ಮೈಕ್ ಆಫ್ ಮಾಡ್ಕೊಂಡ್ರಿ. ನಿಮ್ದು ಗೂಗಲ್ ಮೀಟು ಮೈಕ್ ಆಫ್ ಮಾಡ್ಕೊ. ಅದೇ ದೀಪ ಹಂಗಲ್ಲ ಮೇಡಮ್, ನಾವು ಒಬ್ರು ಅಟ್ ಎ ಟೈಮ್ ಮಾತಾಡ್ತಿರ್ತಾನೆ. ನೀವು ಫೋನಲ್ಲಿ ಮಾತಾಡ್ತೀರೀಗ, ಗೂಗಲ್ ಮೀಟಲ್ಲಿ ಮಾತಾಡ್ತಿದ್ದೀರ, ಹಂಗಾಗಿ ಎಕೋ ಆಗಿ ಬರ್ತಾ ಇತ್ತು. ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಈ ಗೂಗಲ್ ಮೀಟ್ ಆಫ್ ಮಾಡಿದ್ದೆ ನಿಮ್ದು ನಾನಿರ್ತದ ಬೈ. ಈಗ ಅದು ಆ ಲಿಂಕಿಗೆ ಯೂಟ್ಯೂಬ್ ಓಪನ್ ಆಗ್ತದೆ ತಾನೆ. ಆ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡ್ಬಿಟ್ಟು ಅದು ಸ್ಲೈಡ್ಸ್ ಅದು ಶೇರ್ ಮಾಡ್ಲಾ ಅದು. ಸರಿ. ಮಾಡಿ ಹೇಳಿ ಲಿಂಕಲ್ಲಿ ಗೂಗಲ್ ಮೀಟ್ ಆಯ್ತು, ಅದೊಂದು ಹೇಳ್ಬಿಟ್ಟು ಮಾಡ್ರಿ. ಏನು ಮೇಡಮ್? ಅದಕ್ಕೆ ಜಾಯ್ನ್ ಆಗಿರ ಅಂತ ಹೇಳಿ. ಹಲೋ ಸರ್. ಹಾಂ 10:45 ಸರ್. ಇನ್ನೂ ಇಲ್ಲ ಸರ್, ಸ್ಟಾರ್ಟ್ ಆಗಿಲ್ಲ. ಇನ್ನೂ ಲಿಂಕ್ ಕಳಿಸ್ತೀನಿ ಸರ್ ಎಲ್ಲರಿಗೂ ಯೂಟ್ಯೂಬಿಂದ. ಹಾಂ ಸರ್. ಹಾಂ 11 ಆಗುತ್ತೆ ಸರ್. 11 ಗಂಟೆಗೆ ಜಾಯ್ನ್ ಆಗಿರೋದು ಸರ್. ಹ್ಞೂ ಇಲ್ಲ ಸರ್, ಹೇಳಿಲ್ಲ ಸರ್. ಸಾಕು ಸರ್ ನಾವು. ಹ್ಞೂ ಹಾಂ ಸರ್, ಹಾಂ ಸರ್. ಅಲ್ಲ ಮೇಡಮ್, ಈಗ ಅದು ನಾನು ಶೇರ್ ಮಾಡಿದ್ದು ಆಗ್ತಾಯಿತ್ತು ಮೇಡಮ್ ಸ್ಕ್ರೀನ್ ಶೇರ್. ನೀವೇ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡ್ತೀರ ಅನ್ನೋದು ನಂಗೆ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಾಯಿತ್ತು ಅಲ್ಲಿ. ಹಾಂ ನಾನು ಸ್ಟಾಪ್ ಮಾಡ್ಕೊತೀನಿ, ನೀವೇ ಶೇರ್ ಮಾಡಿ. ಅವ್ರು ಏನಾದರೂ ಲಾಗಿನ್ ಆದ್ರೆ ರಿಸೋರ್ಸ್ ಪರ್ಸನ್?
ಇಲ್ಲ ಸರ್, ಅವ್ರು ಕೇಳಿದ್ದೀನಿ, ಮೆಸೇಜ್ ಮಾಡಿದ್ದೆ.
ಹೌದಾ, ಓಕೆ ಓಕೆ. ಚಿಕನ್ ಸರ್, ನಂದು ಮೈಕ್ ಆಫ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀನಿ ವಿಡಿಯೋ, ಹಂಗೆ ಟ್ರ್ಯಾಕ್ ಮಾಡ್ತಾರೆ ಸರ್. ಈಗ ಅನುಷಾ ಮೇಡಮ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊತಾರೆ, ಅವರು ಮಾತಾಡ್ತಿರ್ತಾರೆ. ಯೂಟ್ಯೂಬಲ್ಲಿ ವಾಯ್ಸ್ ಒಂದು ಟ್ರ್ಯಾಕ್ ಮಾಡ್ರಿ ಸರ್ ನಂದು ಮತ್ತೆ ಮಾಡಿರಿ ಸರ್. ಓಕೆ ಥ್ಯಾಂಕ್ಸ್. ಏನು ಬರಲ್ಲ ಅಂದ್ರೆ ಇಮಿಡಿಯೇಟ್ ನಂಗೆ ಹೇಳಿ, ಯೂಟ್ಯೂಬಲ್ಲಿ ಮಾನಿಟರ್ ಮಾಡಿರಿ ಸರ್, ನಾನು ಇದು ಮಾಡ್ತೀನಿ. ಓಕೆ ಓಕೆ ಥ್ಯಾಂಕ್ಸ್. ಹಲೋ, ಗೂಗಲ್ ಮೀಟ್ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ಅದು ಕೊಡ್ರಿ. ಓಕೆ. ಹಲೋ, ಯಾರ್ದು? ಓಕೆ ಓಕೆ ಮಾಡ್ತೀನಿ ಓಕೆ. ಯೂಟ್ಯೂಬ್ ಆಗ್ರಪ್ಪ, ಗೂಗಲ್ ಮೀಟ್ ಫುಲ್ ಆಗಿದೆ. ಯೂಟ್ಯೂಬ್ ಕಳ್ಸಿದ್ದಾನೆ ಲಿಂಕ್ ಅದಕ್ಕೆ. Hello, good morning, Vaibhav sir.
Very good morning, sir. How are you?
Welcome to PC workshop, sir.
Thank you so much, sir.
Sir, here I mentioned one YouTube link, sir.
Yes, sir.
We can go through that one, sir, because more participants are from YouTube only, sir.
Okay, no problem, sir. I'll just check with that.
Okay, fine, sir. Okay.
Yeah, thank you. Thank you.
Hello. ಯಾವುದು? ಯಾಕೆ? ಅಲ್ಲಪ್ಪ, ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಇದ್ದಾರೆ, ಅಲ್ಲ ಹೋಗ್ರಪ್ಪ. ಅದು ಫುಲ್ ಆಗಿದೆ ಸ್ಲಾಟ್, ಅದಕ್ಕೆ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಹೋಗಿ ಅಲ್ಲೇ ಬರುತ್ತೆ. ಹಲೋ, ಹಾಂ ಹೇಳು. ಅದು ಯೂಟ್ಯೂಬ್ ಹೋಗ್ರಪ್ಪ, ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಕಳ್ಸಿರ್ತಾನೆ, ಅದಕ್ಕೆ ಹೋಗ್ರು. ಹಲೋ ಮೇಡಮ್, ಅದಿಲ್ಲಿ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಿರಿ, ಅದೇನು ಮಾಡ್ತಿದ್ರಲ್ಲ ಸ್ಲೈಡ್ಸ್, ಅಲ್ಲ ಗೂಗಲ್ ಮೀಟಲ್ಲಿ. ಇಲ್ಲ, ಈಗ ಆಪ್ಷನ್ ಕೊಟ್ಟಿದ್ದೇನೆ ನೋಡ್ರಿ. ಇವಾಗ ಟರ್ನ್ ಆನ್ ದೇರ್, ಈಗ ಆಪ್ಷನ್ ಕೊಟ್ಟಿದ್ದೇನೆ, ಸ್ಕ್ರೀನ್ ಶೇರ್ ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದೆ. ಅವಾಗ ಆಫ್ ಮಾಡಿದ್ದೇನೆ, ಈಗ ಚೆಕ್ ಮಾಡಿರೋಣ ಸರ್. ಸರಿ, ಓಕೆ. ಬರ್ತಾ ಇದೆ. ಹಲೋ ಮ್ಯಾಮ್. ಹಲೋ ಹಾಂ ಹಾಂ ಸರಿ. ಹಲೋ ಸರ್, ಹಾಂ ಜಾಯ್ನ್ ಆಗ್ತೀರಿ ಸರ್? ಅವ್ರ ಯೂಸರ್ಸ್ ಮಾಡ್ತೀನಿ. ಹಾಂ ಹಾಂ ಹಲೋ.
Good morning, sir.
ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಇಂದ
Hello, sir. Very good morning.
Yes, good morning, madam. Ma'am, can you check the HOD, sir? He's logging on. Nisha, ma'am.
Sir. Shall we start, sir?
1 second, madam.
Good morning, Vaibhav, sir.
Very good morning, Anisha ma'am.
Good morning, sir.
Hello, sir.
Okay, sir.
Hello, madam. Hello, sir.
Can you start, sir?
One second, madam. Yes, sir.
Good morning, sir.
ಅದೇ ಒಬ್ಬರು ಲಾಗೌಟ್ ಆಗುತ್ತೆ ಮೇಡಮ್. ಲಾಗೌಟ್ ಮಾಡ್ತೀನಿ. ಈಗ ಹಂಗೆ ಲೈನ್ ಅಲ್ಲೇ ಜಾಯ್ನ್ ಆಗ್ತಾರೆ ಸರ್, ಒಬ್ರು ರಿಮೂವ್ ಮಾಡ್ತೀನಿ ನಾನು. ಹಾಂ. Hello, Abhishekin. Hello, Abhishekin. Can you log out from the Google Meet? Anyone from? Or can you log out here? Abhishekin or Manohar KM. You can join from the YouTube link here.
Sir, am I audible?
Yes, sir. It's audible. Sir.
Okay. Thank you.
Yes, Anusha madam. Can you start now?
Yes, sir.
Hello. Okay. Abhishekin. Can you log out from the Google Meet? Anyone?
Anusha, madam, you can just mute your YouTube audio. Actually, in your another tab, there is YouTube now. Just click on the mute option in the YouTube. That will not make a difference.
Sir, am I audible?
Yes, sir. It's audible.
Okay.
Yes, Anusha madam. Can you start now?
Yes, sir.
Yes, sir. Hello. Okay. Abhishekin. Can you log out from the Google Meet? Anyone?
Anusha, madam, you can just mute your YouTube.
Sir, am I audible?
Yes, sir. It's audible.
Okay.
Yes, Anusha madam. Can you start now?
Yes, sir.
Yes, sir. ಹಲೋ ಮೇಡಮ್. ಇರ್ಲಿ ಬಿಡಿ, ಹಂಗೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಳ್ರಿ. ವಿಡಿಯೋ ಆನ್ ಮಾಡ್ಕೊಂಡು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಳ್ರಿ. ಓಕೆ. ಹಲೋ ಮೇಡಮ್.
Yes, sir. Is it audible, sir?
ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ.
Good morning, Santosh, sir.
ವಿಡಿಯೋ ಆನ್ ಮಾಡ್ಕೊಂಡು ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. ಎಸ್ ಮ್ಯಾಮ್, ಇಟ್ಸ್ ಆಡಿಬಲ್.
Yes, sir. Good morning, sir. A warm good morning to all. Every day is a new learning, and every learning is an add-on to our knowledge for a better tomorrow. I am Anusha K, Assistant Professor, Department of E&CE, JIT Davangere. Welcome you all gathered here for the 2 days workshop on Pcb Design. In their absence, I would like to welcome Shri Achal Chand Sir, President, JIT, and Dr. Ganesh TB Sir, Principal and Director, JIT Davangere, to this workshop. Good morning, sir. I take this privilege to welcome Dr. Santosh Sheril Sir, HOD, Department of E&CE, and IQAC Director, JIT Davangere, to this workshop. Welcome you, sir. I am Anusha K, Assistant Professor. I would like to welcome Mr. Vaibhav K. Sugandhi, founder and CEO, E&CE Innovation Private Limited, E&CE Innovation Private Limited, to this workshop. Welcome, Mr. President. I take this moment in this auspicious event to quote a mission and vision of our department. The Department of Electronics and Communication was started in the year 2011-2012. The department emphasizes on imparting advanced technical knowledge in various fields like signal processing, VLSI technology, embedded system, wireless technology, microwave engineering, optical communication, microelectronics, and control system. Highly qualified. Welcome, Mr. President. I take this moment in this auspicious event to quote highly qualified and experienced and dedicated staff members are the backbone of our department. Sophisticated precision and state-of-art laboratories are center of attraction in the campus. Another major strength of the department is its extensive collection of technical books, periodicals, and journals. Department of E&CE aims at targeting innovations in the field of advanced communication and networking. And the vision of our department is endeavors to achieve academic excellence by providing value-based education to meet the ever-changing needs of the society. The mission of our department includes to emphasize on student-focused learning environment, to provide a supportive atmosphere which promotes educational, career, and social.
ಅನುಷಾ ಮೇಡಮ್ ಜಸ್ಟ್ ಸೆಕೆಂಡ್ ಮೇಡಮ್ ಅದು ನಿಮ್ದು ಯೂಟ್ಯೂಬ್ ಆಫ್ ಆಗಿದೆ ಮೇಡಮ್ ವಾಯ್ಸ್ ನಿಮ್ಮ ಯೂಟ್ಯೂಬ್ ಕ್ಯಾನ್ ಯು ಲಾಗ್ ಔಟ್ ಫ್ರಮ್ ದಿ ಯೂಟ್ಯೂಬ್ ಮ್ಯಾಮ್ Yes, ma'am. Go ahead.
Is it clear, sir?
Now it's clear, madam. You can go ahead, ma'am.
Okay, sir. The mission of our department is to emphasize on student-focused learning environment, to provide a supportive atmosphere which promotes the educational, career, and social ethics and professional department of the students, and to provide a platform to inculcate spirit and leadership qualities to succeed in the professional career. Now, I would like to call Ms. Varsha, 5th Sem E&CE, Department of E&CE, to introduce our resource person. Over to you, Varsha.
Good afternoon, everyone. It's a great honor for me to introduce and welcome the resource person, Mr. Vaibhav Sugandhi, founder and CEO, E&CE Innovations Private Limited. He has completed his diploma in Electronics and Communications from Government Polytechnic College. Later, he has completed his Bachelor's of Engineering in Electronics and Communications from KLE Technological University, Hubli, with grade A during 2016 to 2019. Along with his engineering journey, he opted for minor degree in entrepreneurship from CTI, Center for Technology and Entrepreneurship Department, and connecting with the technology startups from CTI. He worked as resource person on PCB designings and manufacturing technology. Being a resource person, he used to share all his experience with diploma students of ML Bharat Tech Polytechnic College, Belgavi. He served as embedded system course lecturer for 6 to 7 months and experienced his trainer role in time in Livewire, which was one of the leading offline training centers in India. At present, he is the founder and CEO of E&CE Innovation Private Limited, Hubli. Here, they design and manufacture electronic products with LOT-enabled and data-driven architecture to address global problems with key innovations. He is also the founder and CEO of Unique Tech Designs Hubli. Having Mr. Vaibhav Sugandhi as our today's resource person is an honor for all of us. Thank you for having your time with us today, and we welcome you, sir. Thank you.
Thank you, Varsha. Now, I request our HOD sir, Dr. Santosh Heru sir, to address the gathering present here. Santosh sir.
Santosh sir, is it audible?
Good morning. Is it?
Hello.
Yes, sir,
Yes,
it's
sir.
audible,
Is
sir.
it?
You can start, sir. Sir, it's audible.
Yeah.
Yes,
First
sir.
and foremost, I would like to wish all of you a happy Makar Sankranti, and on this good occasion, as we all have conducted from Jain Institute of Technology, Davangere, E&CE department, it is very good to have such a 2 days online workshop due to the inconvenience in traveling or as such, and to avoid the mass groupings and all, and following the SOPs of COVID-19. It is too good that we are organizing 2 days online workshop on PCB design. So I would also like to welcome all of you to this online gathering. And the resource person, Vaibhav Sigandi, as I heard just now about his introduction. So, a founder and CEO of E&CE Innovation Private Limited, Hubli, he himself serving as a resource person for these 2 days online workshop on PCB design. So, you all are very glad that you are getting such a good resource person who can share his all the knowledge of printed circuit board design. And I hope and I wish all of them to have a patient listening and learn some good things of PCB design out of this workshop, and be able to inculcate the same or implement the same for your mini projects or final year projects. And what else? So if you have already chosen the electronics and communication engineering as your one of the core branch, then this is a very ultra core design, that is a printed circuit board design. Okay, so this is a very like we can say, if the brain, okay, the microcontroller or any controller or processor, if it is a brain of any electronic circuit, then PCB becomes a heart. Okay, so that is the one which PCB is the one which acts as a sandwich between the hardware and software. Okay, so whatever software you write, that has to be dumped onto a board. Okay, so that has to be dumped onto a microcontroller, but microcontroller has to be fitted into the heart called as PCB board. Okay, so the designing of PCB, this is actually a traditional one. Okay, since many 40-50 years ago only, so this PCB has been a hot topic for all the learners and researchers. Okay, so it is a very unique one, and no other technology can replace this PCB. And yes, anyhow, we are about to start this PCB design workshop in these 2 days. So take your own interest, and I think there are a lot of participants. I think as per the information I had with the Anusha madam and Ravi Kumar sir, around 200 participants have been registered for this 2 days online workshop. And this overwhelming response, let it be for the complete 2 days without losing your patience, because that is very much required for this generation. Okay, so patience is a very important. Okay, so online, so due to we are conducting the online workshop, definitely don't distract yourself here and there. Try to get almost all the information which the resource person is going to share. And I also welcome resource person Vaibhav Sugandhi for delivering this 2 days workshop. Hope this will become a fruitful workshop for all the participants, and good interaction between the students as well as resource person. I just would like to wish all the best to all the participants, resource person, and ultimately the organizers also. Thank you all.
Thank you, sir. Thank you for your motivational words and also heartful wishes, and also for supporting us throughout the process of this event. Thank you, sir.
Yeah, glad. Thank you.
Hope you all will have an interesting and joyful learning process. Now, I would like to hand over this platform to our speaker, Mr. Vaibhav, sir. Over to you, sir. Thank you all. Have a happy learning.
All right. It's a very wonderful and very happy moment for me to be a part of this entire event. And thank you so much for entire working staff and the organizer, and also Santosh sir for warm welcome and giving me this opportunity to share my knowledge on this particular platform. So quick check. Am I audible clearly to everyone? First thing, am I audible, visible?
Yes, sir. Is it audible?
Right. Okay. I hope we have participants on YouTube as well. I'm just now checking. 80 people are watching on YouTube, and I think it is already hitting 100 count on Google Meet. So that's a great thing. This is second time I'm looking at my Google Meet, which is hitting 100 count very easily, and this is the second time. Last time when I conducted, there were 300 students who attended. On that time also, we struggled a little bit like this. But I'm really happy for all the effort put behind this particular scene. Special thanks to all people, like I believe Anusha madam has worked on this particular thing a lot, and also Ravi Kumar sir, and maybe there are so many other people who are putting a lot of effort behind this. So thank you so much for everyone giving me this platform for sharing my knowledge, and I hope I'm going to make it as much as best possible from my side. So having said that, good morning to everyone, and happy Makara Sankranti to one and all. So very good morning. You can text to me or chat box in Google Meet, which is open for everyone. Please do not turn on your mic and talk to me, because it's very difficult for us to handle. It's more than 100 people. So better please text me in chat box so that we can interact very easily. So very good morning, everyone. Even for YouTube people also, I'm looking at those chat window. I'm parallelly watching YouTube as well as Google Meet, so no need to worry about it. I'm actively looking at both the things. Okay. So great. Welcome to this 2-day basic workshop, and I have a small slides for you to start with. Let me share my slides. Just a second. I think we have a very good amount of time where we are going to share and discuss a lot of things. 2 days workshop. Each day we are conducting with 2 hours per session, and lots of learning. I personally believe there are fundamentally a lot of learning which you can literally use for your life skill. Okay. I think let me go back to this one. Great. So I hope my slides are visible to you guys. Quick check: audio, video, slides. Great. Okay, so you just give me a confirmation at the chat box so that I can get to know about it very easily. I think in YouTube there is some lagging. I don't know what is the reason for that. It may take another a couple of seconds to reflect on YouTube. No worries, but I'm very sure it will be queued in the streaming. Okay, great. Thank you so much for everyone for your quick response. Okay, Kiran is saying 49-second lag. Oh, you measured with a timeline or something? It's exactly 49 seconds. That's a wonderful thing. If you have a knowledge of such things, that's just amazing. Great thing. Okay, so quickly, I just wanted to start with this particular session because there are a lot of things to discuss, and it's not only limited to PCB designing, it is also limited to your career opportunity, which I'm going to share in this particular workshop. 2-day workshop, it is a workshop. Don't consider it as like an online lecture or maybe a boring class or something. No, it is not. It's a hands-on experience, and it is going to be a practical one, and it is going to be very interactive. Personally, I love to have interactive sessions. So it is kind of a different, and it is a workshop. I'm going to handhold you to develop a single layer PCB at the end of this entire internship or workshop program. Okay. I used to conduct internship a lot, so it by default comes, right? So let me jump into my slides. Okay. First of all, thank you so much for my brief introduction. But still, from my side, I just wanted to give a very quick introduction about me. I'm actually electronic engineer and a passionate engineer personally as an individual. I founded Unique Tech Designs, which is a UTD Hubli, popularly known as UTD Hubli, from 2016, and still now it is running actually, but not in the front end, at the back end, because we started one more company with a big scale and a big private limited structure, that is E&CE Innovation Private Limited. We also call it as E&CE Innovation Private Limited. And recently we also started one more startup, that is Linked Frequency. This is a YouTube channel actually, which is aimed to design and develop courses which are absolutely free for everyone. So you can check about that Linked Frequency in the later time as well. I'll come back to that point in a later stage. Okay, these are the three iconic companies which I started and running right now, and I'm very proud about them because they are serving something to the society. Okay, so this particular workshop is a basic of PCB designing for 2022. Why I'm saying it is 2022? Every year there is innovation. Every year there is going to be a new additional features which are going to change the way in which we are designing a PCB. So that's why I'm focusing more on the next 1 year, because just now we started just a 15 days. So I believe the next entire 11.5 months are going to help you to learn this particular skill and experience the power of this particular tool. Okay, it's going to be a 2-day workshop, and of course it is organized by Jain Institute of Technology, Davangere. I'm very thankful for this organization and the giving platform to me to share my knowledge. Okay, having said that, let's jump onto the agenda for this particular workshop. What is agenda for my 2 days workshop, today and tomorrow? This is complete agenda for 2 days. We are not going to jump into too many topics and make you struggle with identifying what is right and what is wrong. We are not going to do that. Instead, we are going to put ourselves very clean, very organized, and very patiently going to develop something practically that is useful for you, and that you can literally use for your career opportunity, either in mini project or maybe in a major project, or maybe, who knows, you can become a one more PCB designer like me who are working right now in this industry. Okay, so it takes a lot of patience, a lot of understanding, and also very good amount of self-investment to become a PCB designer, because it is not just about technology, it is also about artistic work. It is skill, life skill. Okay, having said that, we are going to jump terminologies first, because they are the most important things. So we are going to discuss about some basic terminologies which are related to PCB industry or designing a tool as whole. Okay, we are going to understand that one, basics of PCB designing. It's a kind of introduction you can consider. Okay, thereafter we are going to start with Is the Eda Tool, which is one of very open source and a popular tool which we use for developing a small scale PCBs, and it is best suitable for beginners, the one who are learning PCB designing for the first time. Thereafter, we are going to talk about introduction to Is the Eda Tool, like what exactly the tool is all about, how the UI looks like, and what are the features available. All those things we are going to discuss in next iteration. Thereafter, understanding and designing a schematic diagram is going to be a major part of today's workshop. Today, we are going to develop a schematic, which is going to be a professional one as much as possible. And I'm going to share you all the knowledge and procedure, protocols, you can say, all those protocols to design your own PCB or own schematic for today. And tomorrow we are going to jump into designing a PCB layout. Okay, there are 2 stages in PCB designing. First stage is all about circuit diagram and a schematic design, and the second stage is all about designing PCB layout, which we are going to discuss tomorrow. Okay, the tomorrow agenda is also added in this particular PPT, which I'm going to use for tomorrow as well. So again, tomorrow we are going to talk about some important of symbols and footprint. What is the importance of symbols and footprints? All those things we are going to discuss. Thereafter, creating a PCB layout is going to be the main agenda for tomorrow. And then we are going to give you a couple of assignments, which are not general assignment like your college, but also something which can turn you into new opportunity. If you can understand this one, if you feel you are connected to this particular industry, and if you feel enjoyment and joyfulness in this particular process, I'm very sure you are going to be a PCB designer very soon. Okay, so we are going to give you a couple of assignments or a minor project for you to complete. This is what I'm going to deliver by the end of these 2 days workshop. I hope I'm making it clear to every one of you, and I'm very sure you are going to expect the same thing with this. Also, I'm just curious to know, are you guys expecting anything other than these things, whatever I put it here? So do you have any expectation other than this? What do you think about this workshop? I just want an interactive session. I think in comment, we can look into the answer. So in YouTube also, I'm looking at the comments, and also in the case of Google Meet also, I'm looking at the comments. So you can just comment me what you are expecting other than these things, or good to go. And I think in Google Meet, if it is possible, you can turn on your mic and discuss to me. But again, a little bit complicated to handle, but I'm okay to look into it if it is possible. By the way, I have a camera here and I'm sitting here. So, I mean, my screen is here. So don't get confused to me. I'm looking at a screen here. When I'm speaking, I look at the camera. So what do you think about this, guys? Are you guys good to go with this? Do you have any comments? Do you have any thought process? Good to go ahead. Okay, that's a great thing. Nagaraj says good to go. Make it interactive session, guys, because 2 days workshop. So we need to be human, not robots, right? We are not robots, by the way. So very good to go. That's a great thing. Let's get started. That's amazing. What about others? I think in all good. Okay, that's a great thing. Okay, making the small backend design is too. Okay, Pooja said in the YouTube, Pooja is saying making the small backend design is tool, sir. I mean, I didn't understood what you are saying, Pooja. Can you say it again, or maybe can you rephrase your sentence a little bit? Okay, let's wait for that. Not an issue. Great. So, what do you think about this agenda, Anusha madam? So, do you think it is going to serve a purpose that you are set for yourself, whatever the goal you are setting?
Yes, sir.
Okay. So, do you have any comment on this?
Yes.
Great. Wonderful. Wonderful. Great. So, I think Ravi Kumar sir is also here. So, what do you think about this, Ravi sir? So is it going to serve the purpose of your workshop, whatever you have planned for?
Yes, sir. Actually, I have some set of goals, sir, regarding that
Okay.
real estate design. So, in order
Mm-hmm.
to make that achieve goals, this PCB is very helpful, sir.
Of course, too.
Already we discussed with the students, sir, in 7th semester and 5th semester. They
Mm-hmm.
are also very interested to attend this workshop, sir.
Amazing, amazing, sir, amazing. I try my level best to serve whatever possible from my side because, as I already said, I'm a passionate PCB designer, so I don't mind sharing my knowledge. So let's see how it goes for the 2 days.
Okay, sir. All the best. Thank you.
Thank you, sir. Thank you so much. All right. So, having said that, I'm very interested to go ahead and start with my workshop. I think nothing much to consider here. I think if you guys are having any questions or anything to be shared with me or any suggestions or anything, you can just text me in Google Meet or maybe in a YouTube live. So probably if it is possible, I'll look into it in between and try to answer those questions or maybe anything. If it is not possible by the end of this entire workshop, I mean by end of today's session, I'm going to answer your question. I'm keeping exclusively a 10 to 15 minutes time for Q&A, which is a question and answer session, where I'm very interested and spending too much of time on understanding what is your question and answering them. Okay, no need to worry about that. There is a specific time for that. Along with that, I believe Ravi sir and also Anusha madam is going to help me if anything need to be noticed to me before talking to the next level. Okay. Having said that, let me jump into the PPT part, continue with my next slide. Okay. So the first thing first, always we need to make sure that understanding the basics are going to help you to understand the topic in a larger context. So we need to understand the basic before using any tool or before using any software, right? So this is all about one technology. PCB designing is a whole technology it is. And then without PCB designing, I don't think so anybody is having any smart gadgets right now. In fact, there is a wonderful story which I wanted to share with you in the coming part of this entire workshop. But do remember, basic terminologies of PCB industry or a PCB designing tool are going to help you lay down the foundation for the building that you are going to construct. Okay. So I think there is one message. No worries. I mean, that's a great thing. So these basic terminologies, whichever we are going to discuss, I'm going to use one more tool for that. Instead of using a PPT, which is a traditional method, I'm very interested to use something called a mind map, which I'm going to use as advanced tool to connect you with a mind map and try to explore a couple of terminologies and basics related to PCB designing. But quickly, let me jump into the next slides and finish a little bit things in this particular PPT. Then I can share you the next slide or maybe next window, which is consisting of mind map. Okay. So first thing, we need to understand that we are using the Is the Eda tool in the entire workshop, which I'm going to explain you, which I'm going to show you how to download, how to install all those procedures. No need to worry about it, which I'm going to share with you, and you're going to install this particular software in your computer, and you're going to design your own PCB by end of this entire workshop. Okay, no need to worry about that. You just need not to look into the screen and enjoy the process. You are also going to experience that particular process in the coming part of the entire workshop. Okay. Then this is how our Is the Eda tool look like, which I'm going to explain you again. No need to worry about it. And then we are going to work on this specific circuit, which is a 5-volt DC power supply, which we are going to design in our entire PCB designing workshop. And we are going to explain you how to design other circuits as well. I'm going to give you a protocol, which is a formula kind of thing, which you can apply for any PCB that you're going to do here and after. Thereafter, we are going to talk about symbols and footprint. Again, when time comes, I'll come back to this particular slide and I'll explain you. But right now, I'll giving you what are the perks available in the entire workshop for 2 days workshop. So keep you connected, keep you hooked to this entire workshop. I need to show you what exactly is waiting for you in the coming part of the story. Okay. So we are going to develop something like this, which is absolutely amazing and looking wonderful to every one of us naturally. So this is PCB designing tool, which is Is the Eda, and we are going to develop such kind of a PCB by end of this particular workshop. Then again, I'm going to give you a couple of assignments like a stable multivibrator and also dual voltage power supply, which we are going to discuss in coming part of the story. Then again, thank you for attending. All those things are there. So having said that, let me stop sharing my screen and let me start sharing the other part of the story, which is all about mind map. I think it is already up. Let me quickly try to share it. Wonderful. There it is. That's not visible. Just a second, guys. I think it is back in. Let me environment. Wonderful. It's here. Great. All right. So can you guys see my mind map? Actually, this is a mind map which I'm using right now. I hope it is visible to everyone in. Okay.
Yes, sir, it's visible.
That's amazing. That's amazing. Thank you. I think it will be reflected in YouTube channel maybe in the later time. So no worries. Yeah, Pooja is rephrased her question, and the answer is yes. We are using a software tool to develop a PCB. Okay, it's a software tool. So okay, so let that answer go and reach to her. Until then, we'll go ahead with the mind map and everything. Okay. Great. So now let me jump into my mind map section. You can see that basic terminologies of this entire PCB industry is going to be a foundation for you, and I'm going to explain them as brief as possible because see, we are all human beings. We love stories, not to remember all the things. Okay. Most of the time it is not possible to remember everything that is around us, so that's why I'm not going to put a lot of technical words or maybe a jargons in front of you to digest for today's workshop. However, I'm going to try to touch upon a couple of important factors or important terminologies which helps you to become PCB designer very easily in the coming days. Okay, so first of all, before jumping into terminologies, I would like to give you one motto behind why we need to learn PCB designing. Of course, you are electronic engineer, you are a part of engineering college, part of diploma college, part of technology world. Because of that, you are here. All those things are okay. But beyond that, do we have any motivation that helps us to keep going even after 1 year? today I'm hosting a workshop, maybe this energy lies with you for another 5 days, 6 days, something like that. If you're just attending for the sake of certificate, or maybe for the sake of attending this workshop because it is a part of your curriculum or something. But beyond that, beyond 5 days or 6 days, or maybe beyond 1 month, if you are really need to stuck with the PCB designing, or if you are really need to be a part of PCB designing community, then there should be certain motivation, right? So that motivation I'm going to talk to you by using a golden circle principle, which is all about why, how, and what. Why we need to learn PCB designing, how we are going to learn it, and what are the benefits of learning PCB designing. These are going to serve you as a motivation factor, as foundation for you to become a PCB designer, if at all, if you are interested towards that industry. Okay, so first of all, let me talk about why we need PCB designing. Okay, why we need to design PCBs, or what is the use of these all things what we are doing. So I have a lot of information about that to convey you why PCBs are important, because I know that, because I'm in the PCB industry for more than 6 years, and I'm a passionate PCB designer. I love designing PCBs, and I might experience the power of PCB designing and all. But to make it simple for you people, technically speaking, PCBs are going to help you to hold your electrical components mechanically strong and in place when you are working with circuits. Okay, so to convey this message, I would like to say that have you ever seen a washing machine or televisions or maybe a mobile phone in your hand coming up with a jumping wires? Have you seen anybody? Again, I need an answer for this because it is going to be an interactive session. So please comment in chat box, or maybe in YouTube chat. Okay. So Venkatesh said yes for that. Venkatesh, can you tell me which location or which particular mobile phone have you seen with the jumping wires, or maybe a wires in all the place? Okay, my mistake. No problem. That's okay. That's okay. So that's what I mean. None of you have seen your mobile phone bulkier, having a lot of wires and all those things. Okay, now let me ask you why we need a PCB. Some people who are not at all aware of what is PCB and all, they might come to me and ask me, why you do all these things? I mean, you are sitting in front of a computer from morning to evening, but you're designing that software work and all, like blue color, red color, looks like a color work, but what is the use of that? Then for them, a wonderful question, I mean, wonderful answer from my side. Look at your table right now, where you are sitting, look at your table. In my case, right now, I have a table here, and in front of table, I have a light source and all those things, camera module and all those things. Look at them. How many of them are electronic gadgets? What do you mean by electronic gadgets? They should be having some electronic circuitry inside, which will help you to achieve what you are doing right now. Look at my camera. Without camera, do you think I'm able to look like this in front of you? Do you think without camera device, I'm able to look at you, or maybe you are able to look at me, look at my hands expression, look at my facial expression, all these things? Is it possible for you without having a camera device in front of you? Impossible. Which is a little bit bigger one. Look at the small light source here. This is also having a one PCB inside. Okay, look at this small size of tube light here, which is again a LED bulb, but it also have one small PCB inside, which is converting into a DC voltage, which is suitable for that particular LED. Not only these small gadgets, look at my computer, which is again having a lot of PCBs inside, not only one, but more than one. And also, what about our mobile phones? Again, they are also PCBs. Not only one, again, more than 6, I believe. Nowadays, it is less than 6 because of optimistic technology and all. But of course, there are more than one PCBs in that particular mobile device. Not only to that, even this mouse, which is wireless, it is having a PCB inside. Look at this keyboard, it is having a PCB inside. Whatnot, if you look at everything that is lying on your table, at least out of 10 gadgets, at least 2 gadgets are going to be a PCB device, having an electronic circuit inside. If there is an electronic circuit, then obviously PCB is going to be a matter of concern. Okay, have you seen any device or any electronic circuit which is not having a PCB? If it is not having a PCB, then it is a project, it is not a product. Okay, let me make it very simple to you. So not only limited to that, even our mobile phone having a small memory card inside, which is again a PCB. And if you look at our microphone, this one, Bluetooth earphone or maybe a wired microphone, again it has a small PCB inside. And if you look at our small gadgets which are like keychains which are having GPS location tracker and all, like Apple tag is AirTag is recently launched one product. Even that small tag which looks like a fancy device or a fancy material to wear for those people who are not having the habit of being in one place, or maybe attaching them to a small gadgets which we are using, that particular device is also having a PCB inside. Look at everything around you and you can notice more than 60% of the material you are using is having an electronic circuit inside, and also they are built on PCB. Okay, I just spoke about a table. Look at your home. Actually, you have a fan which is having a PCB inside. You have AC which is having a PCB inside. You have washing machine in your home. Again, it is having a PCB inside. Not to mention television is having a bunch of PCBs, not only one, multiple PCBs. Nowadays, maybe a single PCB is doing a much of better work with a sleek design and all, but practically speaking, there are more than one PCBs in televisions. Okay, not only to that, in our office right now, I'm sitting in my office. This is our office background and all, but you can see that there is a lab bench power supply here, which is again having a PCB inside. So what I want to say you, what I want to convey you is all about PCBs are everywhere. Everywhere. In fact, you go wherever you want to go, wherever you want to find anything that is a technology solution, there should be a small piece of electronics inside. Without electronics, there is no technology solution. Okay, so these technology solutions, whatever we are using in day-to-day life right now, they are all having circuitry inside, and those circuitries are built with PCB. So that's the skill that we are learning. Are you getting my point? Actually, what is the intensity of this entire skill? What is the level of this particular skill that we are learning? What is the power of this particular skill? Okay, that's why I feel proud about myself. Why? Because I'm doing something that is very rare to see in nowadays people, because everybody is running behind software and all. Of course, I respect software, there is no question. Software and hardware are like 50-50, there is no question on that. But point here is, if everybody does the software, then who will do the hardware? And if it comes to hardware, whether it is a VLSI or a PCB designing, it all requires a different mentality. And that's the reason why we are learning PCB designing. So this is the major motivation factor for you to attend this today's workshop and tomorrow workshop. Can I get a big yes from you, all of you, from assuring me to show up on tomorrow as well? Today I can see 101 here, and I think 92 on the YouTube channel. So pretty much it is 192 or 93 people. Can I get a yes from you, everyone? Can I see you again tomorrow? That's amazing. I can see more than 20-30 people already said yes on that. That's a great thing. Again, in YouTube, it is taking a little bit lag, so I'm okay with that. If I get a yes in a later stage, that's okay for that. No worries. But still, I'm expecting a yes in YouTube channel as well. There is a comment section, right? So please put a yes in comment section. I can see that somebody is typing a yes now. So that's a great thing, actually. Wonderful. Amazing. This is just amazing, actually. I can recall those memories when I conducted a workshop for 300 students last time. Not a workshop, it's an internship program. 1 month we conducted this kind of a workshop for 300 people. On that time also, I used to get these kind of responses. I'm very happy to see that again. Thanks for bringing me that nostalgia. That's a great thing now. Wonderful. Having said that, let me jump into the second point. First point, why we are learning PCB designing. I think you are now clear why PCB designing is important. Now let me talk about the second point. It helps in mass production or mass manufacturing in a faster rate. Now, I think most of you are having a electronic background, I believe. Most of you are from electronic engineering, and you people are having so lot of idea with respect to how electronic circuit works and why electronic circuit works and how exactly electronic circuit works and all. And I also believe that one or other way you people have created some circuit on a breadboard or something, right? Maybe on dotted board or breadboard, kind of a project and all. So do you think can you make such a same circuit with the same efficiency, hundreds of quantities again and again? Can you do that? I'm asking this question to every one of you. Can you do that same circuit again and again, again and again, again and again with the same efficiency 100 times? Absolutely not possible. It is just not possible because we are human beings. We are not robots. Even though we assign a robot for this particular work, it is not possible to expect a better and you can say good result at that particular stage when it is a reflection of design circuits. Okay, so first of all, we must understand that it is not possible for human being to replicate this circuit as fast as required when it comes to designing basic circuit. Okay, so keeping that in mind, what I need to tell you, in mass production, when it goes to big industries where thousands of PCBs are need to be manufactured per day, on that time, just not possible for humans to assign that particular work. On that time, PCB comes into the picture. If you design a PCB, I think I would like to show you something. Yeah, just a minute. I'll just grab some PCBs from other side. In our office, you can see that PCBs are everywhere pretty much. So just I need to grab some PCBs nearby me because all of them are wonderful all the time. So there is nothing to worry about them. Look at this, actually. This is so-called PCB, okay? I'm not sure whether it is too clear to you people or not because we are using a Google Meet and it is over the internet. So I'm not sure about multimedia resolution here, but you can see that this is one PCB, okay? This is the front side and that is the back side, okay? And if I want to manufacture the same circuit 1000 quantity, I need not to do anything. Once I designed it and I made it manufactured by machineries, a bare PCBs, and then I assigned one robot to place components on this and solder it from the backside. This will have a 100% efficiency every time when we manufacture this PCB. No change in circuit, no change in functionality, no change in reliability with respect to time as it goes. Okay, so that is the that is the reason why we go for PCB designing and PCB manufacturing. And when it comes to thousands of PCBs manufacturing, these are going to serve the purpose, okay? Rather than you putting your own hand in designing the PCBs once again every time. You get bored, right? You are a human being, you are not a robot again. So we get a bored even soldering these PCBs. So think about creating a circuit from scratch every time, how boring it is. So that's why we need PCBs. So second point is all about helpful for mass manufacturing and mass production.
ಹಲೋ ಹಲೋ ಮೇಡಮ್. ಹಾಂ ಮೇಡಮ್, ಅದು ವಾಯ್ಸ್ ಬರ್ತಿಲ್ಲಲ್ಲ. ಫೋನ್ ಮಾಡಿದವ್ರಿಗೆ ಅವ್ರದ್ದೇ ಮಿಸ್ಟೇಕ್ ಇದೆ, ನನಗೆ ಕರೆಕ್ಟ್ ಇದೆ. ಹಾಂ, ಹಲೋ ವೈಭವ್ ಸರ್, ಇಟ್ಸ್ ಆಡಿಬಲ್ ಸರ್? ವೈಭವ್ ಸರ್, ಆಮ್ ಐ ಆಡಿಬಲ್?
He's not in the meeting, I think, sir. He left, I think.
ಓಕೆ ಮೇಡಮ್.
He'll be joining back, sir, within 2 minutes.
Okay, ma'am. Hello, Vaibhav sir. It's audible, sir?
I'm audible sir now?
It's audible, sir.
Yeah,
Can go ahead,
sorry,
sir.
sorry. So, yeah,
Okay, no
small
problem.
internet glitch here.
Okay.
Wonderful. Just sharing my screen once again. A moment, please. Back. Great. Yes, so back again. Sorry for that. I just had a small internet glitch. So my laptop got snatched from the internet. Because of that, I'm not able to connect you back. So now I'm back with another internet source. No worries. Just wanted to come back to the point. The second one, when it comes to manufacturing and mass production, it is going to help you with the increase the production rate and keep the efficiency at the top level. That is the reason why we need to learn PCB design. Now let me talk about the next factor, which is all about efficiency, effectivity, and also the durability and standardization. Now, let us talk about a story. I'm a Bible Sugandhi with a passionate PCB designing and all those things, but let us forget that I'm a PCB designer, but I'm a very good in circuit designing. So the way in which I design circuit, say for example on breadboard, if you're hooking up the circuit and all, the way in which I hook up the circuit is always different from the person who is hooking up on the other side. Maybe say for example, on the other side, you are sitting and you are designing a same circuit diagram, everything is same, components are same, material is same, time is same, everything is same. But you have your own persona and I have my own persona. In that case, we are not able to design the same circuit if we are manufacturing it with our bare hand. Instead of that, if one engineer who is a PCB designer sitting in front of a computer and designing a PCB, then it becomes a standardized. No matter whether you solder the component or I solder the component, the circuit diagram remains same. And we can make sure that it is working in all the condition and it is working for all the trials. How many times you manufacture it, no matter how many quantity you manufacture, it is always going to work. That kind of a standardization we can take care when it comes to PCB designing. So these are the three important reasons why we need to learn PCB designing, why it is adoptable, how we are going to use them, and what is the reason why we are designing PCBs and why we are using PCB in industry. Are you guys convinced with this particular concept? First of all, that's my first question to you. Are you guys convinced with the first concept that I shared with you, why we need to design PCB? Oh, okay, we have a lot of comments here. Excellent shelf life, PCB board gives the terms. Okay. Absolutely true, Venkatesh. Your answers are absolutely true. In fact, that is what exactly necessary with respect to PCB industry. Okay, that is the reason why we are PCB designer. I exist because of that only. Of course, PCB designing is my identity. That's why I'm a little bit joyful when I talk about PCB and all. And I don't have limits when I talk about PCB designing. Already we spent 1 hour. See here. Okay, that's a great thing. Great. So I can see a couple of comments with respect to why we need to do PCB designing. I hope everybody is having the same thought process. Though you are not commenting, I believe you are also having the same thought process in your mind. Okay. Having said that, let me jump into the next part of the tutorial so that we can take it forward. Great. So how we can make them. Now we got to know why we need to design a PCB or why we need a PCB in the first place. Now we got to know that particular story. Now let me talk about how we can design them or how we can make them. So first of all, there are several things in that. There are several procedure in that, or you can say when we are developing a new PCB, there is a set of protocol we need to follow to make it standardized and manufacturable and accepted by most of the industrial standards. So to make it suitable for the realistic application, we have to pass through a several procedure, within which I have jotted down only 7 important procedures. But in reality, there are more than this. I mean, I think there are more than 15 procedure or more than 15 steps to develop one successful product in PCB industry. But for your sake of understanding, as it is a basic workshop or basics of PCB designing workshop, and I believe you guys are beginners, because of that, I'm bringing only 7 important steps. So first of all, it is all about circuit diagram. Just a second. I have a habit of having sip of water in between. Okay. So first of all, it is all about circuit diagram. Circuit diagram means what kind of a circuit you want to design. There should be some diagram, right? You should have what component need to be used, how to connect them. I think electronic students are having very great idea about this. So if you are putting a resistor in series, it is going to drop the voltage. That's why it is called voltage divider. If you are going to put a resistor in parallel, it is going to drop the current, keeping the voltage same on the both terminal. So this is all about series and parallel combination of resistor network, right? I think every one of you having basic electronic knowledge are aware of this particular concept. So to identify whether I need to put a resistor like this or like this is going to be the circuit diagram. So circuit diagram tells you what exactly the component is all about and how they are organized in this particular circuit so that we can achieve whatever we want. If it is a 5-volt power supply, we need to design a circuit in certain way, right? That is what we are going to do in the next part of the video, or not video, next part of this particular workshop. And that's all about circuit diagram. Thereafter, you need to convert that circuit diagram, which is usually on the paper, because in our company, when we are designing circuit, we don't use any tool for designing a circuit and all, because it is going to be a hectic work. Instead of that, we give a scratch pad to people, or maybe I personally use a notebook where I literally draw some block diagram and scratch them and then draw something which is suitable and then iterate them until and unless I feel it is a best circuit to design. Thereafter, I find a part number and make sure that that circuit is designed on the paper. Then we convert that circuit diagram on a paper into a schematic by using a tool called Is the Eda. Okay, so schematic design is all about converting circuit diagram into a schematic, which is simulatable, which is a digital circuit, which is accepted by industry. Okay. Thereafter, we are going to design a PCB layout, as I already shown in a blue color with a UTD logo and all. That particular circuit, I mean that particular PCB we are going to design. Thereafter, we are going to talk about generating the files for manufacturing, which we are going to send them to the manufacturing house where the PCBs are fabricated. And then we are going to procure component that is called a bill of material, which is shortly called as BOM, bill of material. And also Gerber files are the files which are given to the manufacturing house so that they can manufacture it and send us a bare PCB like this. These are the bare PCBs. Okay, there is no component. So these are the manufactured in another industry, which is so-called PCB fabrication industry. Then after that, these components are placed by humans and soldered if it is in a smaller quantity, say less than 1,000 pieces and all. If it is greater than 1,000 pieces and you need it in a quick time, like less than 1 week or something, then we also have a machinery for that. Altogether, whether it is assembled by human or assembled by machinery, it is so-called manufacturing industry or assembly house. We generally call it as assembly house. This is a fabrication house. This is assembly house. Thereafter, it comes to, that is what PCB fabrication and assembly is explained to you. Thereafter, we come to, it will come to us actually as a designer, it will come to us where we put software inside. If it is any microcontroller inside or any microprocessor or any programming device, we program them. That is called a firmware. And we verify whether that firmware is working or not, whether this PCB is working or not, whether the circuit diagram, whichever we designed, is really working or not. It is possible, though I am an experienced PCB designer, even I make a mistake when I'm designing. That is the natural nature of, it's the nature of human being. So we do the mistake, right? So we will identify whether there is any mistake need to be corrected or it is working absolutely fine. All these activities called board bring up activity. So once we do the board bring up activity, we will get to know whether the product is successfully launched or not. Once it is successfully completed at technological level, we will send it to the marketing people, or maybe the people who are branding it, or maybe the people who are installing this particular PCB inside the big machines or something. Okay, that's how PCB designing stages are all about. First one is circuit diagram, second one is schematic design, third one is PCB layout, fourth one is Gerber file and BOM, then PCB fabrication, then PCB assembly, and then comes to board bring up and a firmware activity. I hope you guys are clear with these 7 important steps. This is how PCBs are made. First one we discussed why we need to PCB. Now this is how PCBs are made. So what do you think about this, guys? I just wanted to ask you a question. I want this to be interactive, as I already said. So I like to have more dialogue from you as well. Okay, so there's one question, I believe. Of course, that is true, Manjunath. So once we print the PCB, we cannot change it. So once I print this PCB, now only in our office, this PCB is printed, I think in 2019, I believe. I cannot change anything. Oh, sorry. I cannot change anything. I cannot do anything with this PCB. Once it is printed, it is printed. We cannot do anything. If you want to modify anything, then you have to print this PCB once again. That's why it is called iteration. This is the first iteration. If there is any changes need to be done, then we'll do it and we'll print it again. That is the second iteration. Then again, if there is any mistake again, by chance, if you have made one more mistake, then again, you are going to reprint it once again. So this is how it is called the iteration process, iterative process. But once you achieved what exactly you want at the end, then you need not to worry about redesigning the PCB. It's all about mass production, copycat. You just, print the PCBs again and again, as much as quantities are required. No matter whether it is a 10 quantity or a 10 lakh quantity, it doesn't make any difference to you as a PCB designer. That's the beauty of PCB industry. So what do you guys think about these 7 procedures I said, or 7 steps which I shared with you? What do you think about it? Do you think it is really possible for you guys to complete within 2 days? Prajwal is saying, as he worked in some company as an assembly engineer, I believe, not sure, there are more ports are seated in PCB board. For what reason, I really don't know, but every PCB is different actually. If PCB is application of that PCB demands to have multiple ports for connecting some sensors, actuators, or peripherals or something, then of course we need to do that. That's how design is all about. We can't do anything with that. That is how the design is all about. What if we can make a design which can be updated? It's not possible, Manjunath. That's what I'm saying. It is possible to certain extent. That is what I'm saying. To certain extent, it is possible. We can put some jumpers here, some setting resistors over there, which will help us to configure this PCB for multiple application. Like, this PCB ka one GPIO, one particular pin of this particular component is connected with a 2 component. Let us assume we can make small switch kind of action in between. If you want, you can solder here, then it becomes one application. If you want, you can make a solder here and it becomes one more application. But matter of fact, if you want to add one more third application after 10,000 manufacturing, you have to redesign the PCB. There is no possibility that you can make some jugaad and create something like that. That is not possible because it is a hardware. It is not a software. Even if it is a software, we need to write a code and update it, right? The same way, even if it is a PCB, single layer PCB, we have to redesign the PCB for specific updates if it is not considered in the time of first design. All right, so having said that, let me quickly have a look into YouTube as well, because my friends are joining me on the YouTube as well. I believe there are a lot of people, 93 people are watching on YouTube. That's a great thing. Keep watching, guys, and I'm very sure you are going to enjoy the process. Quickly, we are going to done with the theoretical part, no worries. So this is all about how we make PCB. Now let me talk about what are the tools we can use for designing. this is wonderful way of getting motivated, right? Why we need a PCB? First thing, we got to know the fundamentals of PCB, or maybe why the PCBs are exist in this particular world. And the second one is how we can make them. There are several steps, but I charted down them for 7 easy steps to understand for you people. Then we have tools. What are tools we can use for developing these PCBs? Again, there are several tools available for designing PCB. In fact, if you look at my experience with the 6 years of industry experience, I could say more than 100 tools are available in the industry. Some are very popular, some are not so popular. Within which these tools, whichever I have listed down in front of you right now in screen, whatever you are seeing, these tools are very, very popular one and easy to access. Within which, again, EasyED is a free tool available for everyone. Anyone can use this particular tool, and it is absolutely free for at any cost. Okay, so that's why we are choosing EasyEDA for this particular workshop. There are other tools like Eagle, Proteus, Allegro Cadence, KiCad, Altium. These are the different tools available. Again, this Eagle, Proteus, and KiCad are very limited feature, beginner level kind of a tool. If you want to develop say 4-layer PCB, 6-layer PCB, something like that, on that time these tools are going to help you. Wherein Allegro Cadence and Altium are like a giant. They are king of this entire industry. They are having a very high-end features, very high-end possibilities to design very high-end products. Like, say for example, this laptop motherboard could be manufactured or could be designed in Altium software. That kind of software it is, Altium. Okay, Cadence is again even more better than Altium. But whatever we are using, EasyEDA is also a very good tool for beginners, but not suitable for industrial grade. In a larger scale, after say 4-layer PCB, if you go for a 6-layer PCB designing and all, then EasyEDA is not going to help you too much. But still, you can achieve your requirements, but not recommended actually. Okay, these are the different tools available. I'll not spend too much time on this because it is not necessary for you. Do remember, I highlighted as well, EasyEDA is a tool which we are using for this today and tomorrow workshop. Okay, these are the different tools available for that. Okay, after listening to this why, how, and what, the golden circle, what do you think about this? Do you think it is interesting to learn PCB designing? Yes or no? Is it PCB designing an interesting part to learn? Yes or no? I can see yes from several people on the chat box. What about others? Only few are responding on chat box, not too much people. Lazy? Saturday, holiday, it's lockdown outside and we are sitting in a home in a comfy chair and all. Couch potatoes, come out of. Great. I can see a lot of people. I think there is no response on YouTube chat actually. What is the reason for that? I really don't know. Guys, I'm watching you. Don't think like that. I'm only focusing on what is this? Google Meet. No, I'm watching you on YouTube as well. I can see your chats and I can literally see your chats on YouTube as well. So please comment me so that I'll get to know whether you are connecting with this particular topic or not. So I can see a lot of responses in the chat box and having a good information. Amazing. So let me jump into the next part of the story, which is a very important one again, and I'm sure it is going to be helpful for you. Okay, I'm very sure on that. So first of all, let's understand, now you understood that why we need to learn PCB and how they are designed and what are the tools we can use for designing a PCB. Now let me talk about the basic terminologies. Which are the terminologies which we are going to use for designing any PCB? First thing first, there are several terminologies which you have to know before jumping into the PCB designing. I'm going to touch upon them. I'm not going to dive deep into these particular topics. I'm going to touch upon them and I'm going to give you a glimpse about these terminologies so that you can remember. If possible, I highly recommend you guys, if it is possible, take pen and paper and make a note of this, because this is going to give you very good foundation for becoming a PCB designer. If you guys are really interested to become a PCB designer in the coming days, then these terminologies are going to help you a lot. So before jumping into this terminologies, I have one more important question, both for Google Meet people as well as for YouTube attendees. So after listening to why, how, and what, do you guys think you want to become PCB designers? Do you get motivated to become a PCB designer? Do you get inspired by these stories or maybe the explanation which I have given help you to become a PCB designer? Yes or no? 1, 2, 3, 4, 5, 6, 7. I think Venkatesh, you commented twice. So 7, 8, 9, 10, 11. Oh, that's a great thing. 12, 13, 14, 15, 16, 17, 18, 19, 20. 20, only 20 out of 100. Okay, 21, 22, 23. What about others? 23, which is 23% of 100. 24, that's a great thing. 25, 26. I'm still counting, by the way. 27, 28. 29. It is hardly reaching 30%. I think let me check with I think in YouTube chat is disabled, I believe. I'm not sure. Please check with that. If it is disabled, please enable that one, because there are some people who are interested to interact with me in chat window because they cannot talk to me directly. I inform please to turn on the chat window in YouTube. Okay. All right. I think I can see more than 30 responses in a chat window in Google Meet alone with 100 people available, saying that 42. Oh, that's a great thing, Venkatesh sir. 42 people are saying they wanted to become PCB designers. That's just amazing. I'm very happy for you guys. Let's see how many of you are going to be a PCB designers in coming 1 year. Okay. Great. So in YouTube again, it is still not enabled, but I'm not sure whether it is possible.
Sir, it's coming, sir. YouTube chat, it's on.
Okay. Okay, fine.
In my side, it's on, sir.
Okay, even I tested. It is on. No worries.
Okay.
Maybe people are not texting. That's no worries. Let it.
I'll
be.
check it, sir.
No problem. Yep. Great. So now I think more than 40% of you are interested to become a PCB designer. For you guys, I'm very sure this is going to be the wonderful part of the story, which you have to understand what are the basic terminologies of this entire PCB industry, so that you can literally learn and understand how you can implement this particular skill into the reality. In fact, if you wish to, you can create a career out of this. Possible. That's what I did actually, right? I was also a student like you back in 2015-16. But when I started designing PCBs, when I started learning these PCBs, unfortunately, I couldn't have such kind of exposure like you have, calling some resource person and explaining PCB design and all. It's really amazing that you guys are having this opportunity. But on that time, I couldn't have that. But still, I tried to manage to become a PCB designer with that little motivation, with that little internet, little gadgets, little computer, and all those little limited resources. But now you guys are having a huge resources. Only thing that takes you is all about your interest and enthusiasm to become a PCB designer. Think about it and take it forward. Having said that, there is some comment, I believe. Just let me check with that. Great, no worries. Wonderful. So let me talk about some basic terminologies with respect to PCB designing. First of all, there is something called PCB layers. PCB layers are nothing but the copper layers on the PCB. I would like to show you a live PCB so that you can understand it very easily, visual impact. So let me try to open my another software. I think I'll open my software first and try to share that with you completely. I'll share the whole screen with you so that you can get to know about it very easily. All right, so entire screen, I believe, coming up. Here it is, going out. All right, so I believe you guys are able to see my whole screen. This is a mind map. Again, I'm not able to go back to chat window because it will create a ripple effect on the screen, but that's okay. This is all about mind map. I'm going to pick one one after the one these terminologies, and I'm going to explain them with respect to this tool. This is our PCB designing tool. This is Is the Eda. I hope you guys are able to see this Is the Eda tool. Are you guys able to see this one? Yes or no? I think yes, I believe. Are you guys able to see this screen, Is the Eda screen? Oh, okay. You are texting in chat box. I'm sorry, guys. Please give me a voice command sometime, because when I'm looking at the tool like this, then when I'm sharing my entire screen, when I go back to that screen which has a Google Meet, then it will create a ripple effect. That's why I request any one of you take a volunteer and give me a voice command if I ask a question, if it is related to general one. Just help me in that process. Okay, let me come back to the point here. What is this PCB layers? PCB layers are nothing but number of copper layers in this particular PCB. Now you can see that there is something called top layer. There is something called bottom layer. So bottom layer is all about the copper on the bottom side. Even if you go at this particular PCB in camera, you can see that this is a copper layer actually, where you have a tracks, right? The physical tracks and all. If we have a tracks on this side, this is called a single layer PCB, because it has a tracks only on the bottom side. There is no track on the top side here. Top side, there is no copper only. There is no single piece of copper on the top side, only copper on the bottom side. Then it is called a single layer PCB. If we have a copper on the top side as well as on the bottom side, then it is called two layer PCB, because there is a copper on the other side and here side also. So it is called a two layer PCB. That means number of layers of copper you have in your PCB is going to define how many layer PCB it is. That is all about PCB layers. Okay, so say for example, in our mobile phone or in our laptop and all, there are some very compact PCBs with a high-end technology and all. What they are doing is they are having a multiple copper layers sandwiched between two ceramic plates. Okay, so it's like a sandwich. Like right now I have one copper layer here, and let us assume there is one more copper layer here which is having a little bit of tracks and all, and here is also one copper layer, here is also one copper layer. We'll put some insulating material in between, and I'll sandwich these two PCBs like this. Then it becomes a 4-layer PCB. Yes or no? Individually it is a single layer PCB because there is no copper on this side, but I'll assume there is a copper on the other side. Then it becomes a 2-layer PCB. If I assume both PCBs are having a 2-layer and I sandwich them in between with some insulating material in between, then it becomes a 4-layer PCB. Like this, in India right now we have 64-layer PCB fabrication. 64-layer. Could you imagine how complicated it is? And that kind of a PCBs are used in defense and ISRO and all these satellite application and all those things, which are very high-end applications of the entire industry. So in that case, we use 64-layer PCBs and all. But in our company, naturally, we use single layer and 2-layer in large quantity. But sometime we go with a 4-layer PCB, 6-layer PCB, and all those things. That's what all about PCB layers. Okay. Let me jump into the second point, which is all about PCB vias. PCB vias are nothing but the connecting pads. What do you mean by connecting pads? Let's say for example, we have a copper on this side and we have a copper on this side. If I want to connect a copper from this side to this side, do you think I'll bring a wire from this side to this side? Do you think we are going to solder a wire from this side and this side? Not possible, right? And not recommended. PCB is meant to replace your wires, but we are using a wire from another side to another side, which is not at all a common sense, right? So for that reason, we need something which will connect one copper from the top side to the copper of the other side, or maybe the bottom side. That particular connecting pad is called vias. Okay, we usually often heard that, right? Where you are going. I'm going to say Belgaum, Hubli. I'm staying in Hubli right now. So if I'm going to Belgaum, I'll go via which one it is, Kittur, via Kittur or via NH4. We used to say that, right, in traveling and all. The same terminology applies to this one, but the concept remains same. So PCB vias are nothing but the tunnels or maybe the place where it connects from one copper layer to another copper layer, especially top layer to bottom layer. You can see the example here. You can see here. This blue color track indicates it is in the bottom layer, and the red color track indicates it is in the top layer. You can see that when I toggle to top layer, you can see that there is a top layer indicates. And this top layer copper is connected with the bottom layer copper by using a small pad here, which looks like a small drill hole or something. That is called a via. Okay, so generally do remember vias are the connecting point from one copper layer to another copper layer. Are you guys clear with this? I hope you are clear with this. Again, I cannot come back to this Google Meet and all those things. Now let me talk about the sides of PCBs. What are the sides of PCB? I'll jump back to our Is the Eda tool, and I'll try to use a 3D model of this particular PCB, which will easy for you to understand, easy for you to adopt and all those things. Okay. Can you see this PCB, guys? A blue color one. Can you see this one? Can somebody give me a voice commands at yes or no?
Yes, sir.
Great. Thank you. Thank you. Thank you. Wonderful. So what is the sides of PCB? We spoke about the layers of PCB, right? Now let me talk about sides of PCB. Can you see the components on the top side? We have some white color border on each and every pad here and all those things. Those are so-called components. We solder components on the top side. You can see here. There are some components which I solder on the top side. If I'm placing components on the top side and I'm soldering them on the bottom side, and there is no component placement from the bottom side, I'm not saying about soldering, but I'm saying about placement of the component from the bottom side. In that case, it is called single-sided PCB, because on the only one side we are putting the component. Yes or no? But if we are putting component on the bottom side as well as on the top side, then it becomes a two-sided PCB. Okay. In this example, in the screen also, you can look at into screen. There are some components which are placed on the top side. There is no component placed on the bottom side. You can see here. There is no white color track or white color indication on the bottom side. Only on the top side, you can see all that white color silk layer and all those things. That means it is a single layer of, not single layer, it is a single-sided PCB. There is no component on the other side. That's why it is single-sided. Now, I want to ask a very tricky question to you guys. It is possible to have a 4-layer PCB, because number of copper layer, we can go up to 64 layers in India right now. But in China, it is 84 layer. That is a different story. Copper layer wise, we can go up to 64 layer. But with respect to sides of the component or sides of the PCB, do we have anything like 4-sided PCB? Do you think we can build 4-sided PCB? 4-layer PCB is possible. That's what I'm saying you. But what about 4-sided PCB? This is a 1-sided. If I place a component on the other side, it becomes a 2-sided. Similarly, can we make a 4-sided PCB? Do you think about it? What do you think about this?
Yes, sir.
Why you said yes for that? Can you explain? I'm sorry, I cannot say your. I cannot see your name. So please go ahead and explain me. Do you think we are possible to make a multi-sided PCB, not layer? I'm saying. One who said yes for that, please explain me. How do you think it is possible? Or if it is not possible, also how do you think it is not possible? I think you guys can talk to me directly rather than texting in the chat box, because I couldn't see the text message by natural. I mean, I just need to go back to that window and need to check with that, which is a little bit difficult. That's why if it is possible, please let me know directly. Again, no text. That's what I'm saying. Please try to talk to me directly. 3 single layer and 1 ground layer. Manjunath, that is what I'm saying. Please pay attention to my words. What I said is, with respect to number of layers, we have multi-layer PCB. We can go for 4 layer, we can go for 6 layer, 8 layer, and all those things. But with respect to sides of PCB, that's what I'm saying. Sides of PCB, placing component. Do we have anything called a 3 layer or a 4 layer? Not layer actually. 4-sided, 3-sided PCB. Do you think it is possible? That's what my question is all about.
I don't think so, sir.
Yes, that's a point actually. That's a point. So every one of you who are listening to this particular workshop, make sure that you understand the basics very clearly. Without understanding the basics, you will end up nowhere actually. So it's like a base platform. If you can't stand on foot properly, then how can you balance yourself on a body, right? So that's the reason why I'm forcing too much about this particular concept. We can place a component on this side and we can place a component on this side. Do you think we can place a component on this side? This is a sleek PCB, just 1.6 mm PCB. Do you think we can place a component on this side? Yes or no? Yeah, no, not possible. Absolutely not possible. Okay. And do you think can we place a component on this side also? Not possible. This side also not possible. This side also not possible. That means we can have only two-sided PCB. We cannot have three-sided, four-sided, five-sided, six-sided. Not at all possible. Okay, not at all possible. Technically, common sense wise, intelligent wise, whatever you come up with, there is no possibility of multi-sided PCB. There is a possibility of multi-layer PCB. That's what I'm saying. Layers and sides are completely different. Don't confuse yourself. Multi-layer in the sense number of copper layer, but multi-sided is just impossible. Two-sided PCB is maximum possibility in the entire PCB industry. This is all about with respect to sides of PCB. Now, remaining concepts are very simple, so I'll quickly jump into them and I'll quickly finish them. We are running out of time. So terminals and connectors. So as I already said, if you want to connect wire to this particular PCB, you should have some connector here. If you want to put some Berg strips or connectors to the components inside and all for external board or connecting multiple PCBs one to each other, then you need some connectors and terminals. Those are so-called terminals and connectors. And not to mention, these terminals and connectors are always placed at the edge of the PCB like this. You can see always they are placed at the edge of the PCB and facing outward. Of course, you cannot place them inward and put the wire, right? It's a common sense. Then let's come to the topic called the track width. What is the concept of track width? If you go to Is the Eda Tool once again, if I go to this layout, you can see that there is a big blue color track here, right? So this blue color track have its own width, which is so-called track width. And this particular track width is designed based on the amount of current flows in that particular track. It is like, you can consider a pipeline. Because it is quite easy for everyone to imagine, right? There is a pipeline from overhead tank to your tap water, which is a 1-inch pipeline or maybe half-inch pipeline, and all those things are there. If you increase the diameter of the pipeline, the amount of water flows will increases, right? So based on the amount of water you want to flow with that particular tap, you have to choose the pipe. Like usually people go with a 1-inch pipe, but most of the time they go with a 2-inch pipe also if higher amount of water need to be flowed in that. The same way with respect to track width, we have to calculate the width of the track based on the amount of current flows in that. If it is a 1 ampere of current, then less than 1 mm track width is sufficient. If it is 20 ampere of current, then it is going to be more than 2 millimeter, which is 2 mm track width, and so on and so forth. Okay, there is a particular formula for that actually, which we are not going to discuss throughout the workshop, but still do remember the track width is directly proportional to the current amount of current that flows in that particular track. Thereafter, we come to the clearance and isolation. Clearance and isolation is all about what is the distance between this track to this track. I hope you guys are able to see my screen and also my cursor. You can see that there is a difference between this track to this track. Or if you look into this particular example here, you can see that there is a small difference between this track to this track. There is no copper in between. To avoid short circuit, we need to maintain certain distance between one track to another track. That is called clearance. Okay, and isolation is all about one component to another component. If I place this component here and another component on that on top of that component, do you think it is possible to solder on the PCB? Say for example, here only I have one small IC here. If I place IC here and upon that I'll place one more connector on that, do you think it is possible to physically solder on that? Do you think it is technically possible to solder those components in the same place?
No.
That's what. To avoid such kind of a collision, we place those components with a little bit difference between them, little bit isolation in between. That's called isolation. Okay, so clearance and isolation, very important topic. Thereafter, we have something called footprint and symbol, most important thing. I think I'm not running out of time, but still, I just wanted to come to that point. footprint is nothing but the component position where you are placing and how you are placing. Just to mention in a simple word, if you go to schematic diagram, this is so-called schematic diagram right now, whichever you are seeing in my screen, this is so-called a schematic diagram. So whatever symbolic representation you are seeing here, you can see this resistor symbolic representation, which is natural, which is general, and it is IEEE standard. So this particular symbolic representation is called a symbol because it represents something, right? This particular symbolic representation is all about resistance. How about capacitor? We know that the capacitors are represented like this. And what about these ground symbol? We have something like this. Okay, what about LEDs? They are something like this. This is how we learned basics of electronics, right? So these are all symbols. But when it comes to PCB, we need to solder those components. I think you guys are very familiar with this. Resistors are also having a 2 legs. Capacitors are also having a 2 legs. So you can place them on the same footprint, right? I mean, you can solder, if there is a 2 particular drill hole on this particular PCB, either you place a resistor over there, you place a capacitor over there. It is left to you, right? But to avoid such kind of a mistake, I mean, it is a mistake, by the way. So to avoid such kind of a mistake, there is a specific pattern given to the drill hole that helps you to identify whether it is a resistor pad or it is a capacitor pad. Okay, so that is called footprint. So symbolically, this is how it looks like. When it comes to layout, PCB layout, there is something called a footprint. This is a footprint. You can see here. Whatever you are seeing here, this is a footprint. And if you look at IC, IC has its own footprint. See here. This is a footprint of IC, wherein the symbol of that IC is all about like this, where it is. Here it is. Look at it. All the pins are collected in one place. That is quite natural because it is a symbol. But when it comes to footprint, we have to follow the international standard. The manufacturer has given certain standard for that, and we need to follow that, and we have to create a footprint on the PCB and then use it for connecting a track. One point to another point, copper connection, right? So this is a very core difference between symbol and footprint, and they are the integrated part or building block of entire PCB industry. Okay, so we'll talk about it in the later time. There after we have something called a silk screen and a solder mask. It's again very important. Of course, every terminologies here are very important to us, but I feel these certain terminologies are very much important. You can see here there are some soldering points. When I'm soldering one pad here, it should not get connected or it should not get merged with short circuit with a neighboring pad. For that, we need to create a certain isolation. Or maybe you can see this green color paint is applied on this. By the way, it is not a paint actually, it is a special kind of material which we call it as silk screen. This particular paint will avoid this copper to get the corrosion, because if I keep a bare copper to the air because of moisture and humidity and temperature, it will start reacting as a zinc. It will release the zinc and it will become start corrosing. Actually, we know that, right? So that is how the metal objects are dissolved in over the period of time. To avoid such kind of ionic reaction, we are having some isolating material here, which is green in color, and that color or that kind of a material is called a solder mask. Actually, solder mask. Silk screen is all about white color indication. In PCB, I think here you can see that in PCB. When we go for a 3D modeling, you can see this, you will get to know where to place the capacitor by using a silk screen. Without silk screen, let me remove the silk screen. Now tell me, where is the capacitor? Can somebody tell me where is the capacitor? Can somebody tell me where is the push button? Can somebody tell me where is the 22 microfarad capacitor? By looking at this particular PCB right now in the screen, can somebody tell me where is the specific capacitor? What is the direction of the capacitor and all? Not possible, right? Yes, exactly. It is very difficult to identify which component goes in which particular pad and how to orient it, like positive and negative and all those things. For that matter, we need silk layer. Now you tell me, where is the R2 resistor? Everybody can show it to me. Sir, it is there. That's the beauty of silk layer. So that is the importance of solder mask and silk layer. Now let me jump into the next part, that is SMD and THT. Again, SMD stands for surface mount device, THT stands for through hole technology. To make it simple for you guys, if any component, where it is, here. So if any component or any electronic component that is placed on the top side and soldered on the bottom side, it is through hole technology. With one hole, it will pass its leg through the hole. That's why it is called a through hole technology. So if we are placing a component here and if we are soldering on the other side, then it is called a THT component. If we are placing a component here and we are soldering there itself, there is no drill hole on that particular pad, then it is called SMD component, which is surface mount device. It is mounted on the surface, soldered on the surface, placed on the surface itself. There is no through hole. That's why it is called SMD component. Not to worry too much about it, just for your sake of knowledge, we are keeping it. Thereafter, we have a schematic and layout. As I already explained, schematic is all about symbolic representation. Schematic is all about symbolic representation of the electronic circuit and organizing them in a specific structure. And then when it comes to layout, it is all about copper design. You are going to do the same thing actually. Whatever you have done in the schematic, the same thing you are going to do in the layout. But again, it is a little bit artistic work and a completely different skill. So this is all about layout. This is all about schematic. Are you guys clear with all these basic terminologies? I think we have, yeah, I think we have spoke about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wonderful. 10 important terminologies we discussed. So are you guys clear on these things?
Yes, sir.
That's amazing. That's amazing. Let me stop sharing now and let me look back into the people. Great. Again, we have a lot of comments and also 97 people showing up in chat box. And here we have, again, in YouTube also, I believe you guys are learning from this particular tutorial or maybe the workshop, and I feel you are enjoying too. That's a great thing. Let me check with the next step. Let me check with the next step. What is the next step? Okay, so next step is all about creating account in Is the Eda and starting with designing actually. Let me share my screen once again. Great. So now, so far and so forth, we have completed why we need to learn PCB designing, how we need to create a PCB, what are the protocol for that, and then what are the benefits of creating a PCB, and how we can create them, which are the tools we can use. Thereafter, we discussed about the 10 important terminologies which are essential for PCB designer to understand at the beginning stage. Okay, and as I already said, this workshop is all about basics of PCB designing for 2022. So make sure that you consider them as the basics. There are a lot of things to learn along with this, but you have to spend the time for that. It is not possible in 2-day workshop. Now we'll talk about the Is the Eda tool. Now we understood why we need to learn, why we need to do all these things, and all the effort that we are putting together here. It is all because of making you ready for understanding the basic terminologies and understanding what we are going to do here and after. So first thing first, we need to start with Is the Eda tool. We need to download Is the Eda tool and we need to install it in our computer, and we have to create account in that particular tool and start working on Is the Eda tool. So can we start doing it right now? Everybody, I want yes from everybody.
Yes, sir. Yes, sir.
Great.
Yes, sir.
Amazing. That's amazing. I can see the chat as well right now. So you can text me in the chat as well, not an issue. Just before that, I mean, just before jumping into downloading Is the Eda tool and all, I just wanted to ask you, is it interesting? This
Yes,
PCB
sir.
designing, whatever you're talking, is it interesting?
Yes, sir. Yes, sir.
That's amazing. If it is making interesting things to you, or if it is bringing you back on this particular platform and designing, then obviously I'm very sure it is going to make very good helpful for you. Absolutely, very much. That's a great thing. Thank you. So somebody is raising a hand actually. I think you can directly talk to me. There is no necessary that you have to raise a hand. Anusha, please wait for the attendance sheet and all those things. Just need some time to complete on that. Okay. Yes, Nagaraj, you are right. Actually, there are a lot of things to play with Is the Eda tool, and if you really love artistic work, if you really love designing tools, and if you really love something related to artistic mind, then I'm very sure you are going to play with this particular tool as something like your hobby rather than treating it as a curriculum in your college. That's how I became a PCB designer, by the way. So there's an interesting story behind it. Great. So very well, very amazing things to know about it. And let me jump into downloading ECEDA and installing, and then starting with going with okay. Oh my God, I think I need to refresh YouTube, I guess. I'm not sure. Just let me check with that. Oh, a lot of comments on YouTube actually. I just missed it. I'm very sorry for that. Let me check. It is interesting. So many people are saying it is interesting, clearly visible. Okay, that's. Oh, somebody said it's not clearly visible. I think in YouTube you have option to change the resolution. Please check with that. Sai Suchet. Yep, Sai Suchet. Somebody said, Pooja said, not possible with the foresight. That's a great knowledge, knowledge, Pooja, that you are grasping in this workshop. So you got to know that at least it is not possible in the foresight. Okay, that's a great thing. Wonderful, amazing. So this is really amazing. So let me jump into the next part of downloading the tool and installing it and all this thing. Theory is enough. So far we are done with the theory. So let me give you 5 minutes of time to ask me any questions if you have. 2 to 5 minutes of time, not more than that, just to take myself a little rest. So if you have any questions related to theory, that that's amazing. That's amazing. Thank you. Okay, so do you guys having any questions? Meanwhile, okay, so while you're asking questions, you can download Is the Eda Tool. So let me quickly share it to you. Okay, there is some question, I believe. So Kiran is asking, why does solder mask come in different color? Yeah, this is a tricky question. I love black color the most, so I want black color. That's how black color came into solder mask. And green color is very easy to produce, very cost effective, and very generally available in the nature. I mean, when we extract black color solder mask, it is quite easy for, not black color, green color. When we are making a green color solder mask, it is quite easily available in the natural resources. That's why green color solder masks are very popular than any other color, wherein some companies, to create their identity, create their uniqueness, they wanted to go with a different colors. For example, white color solder mask is also there, black color, red color, blue color, and green color is already there, and even white color most of the time. And there are some technical reason for that as well. Say for example, if you are making a LED board, so some LED boards are there. In that case, we go with the white color. Why? Because the white color reflects LED much better. I mean, reflects light much better than any other colors. So in that case, white color is essential. Not about identity and fancy thing. It is becoming essential. That's why we need a white color solder mask in that case. Wherein with respect to personal PCBs, like one which we developed for us, in these case, we can say that using green color is quite normal and quite cost effective, you can say. That is why it is available in different color, and it is a personal choice which one to choose. Well, Is EDA, right? Is EDA. Oh, no. Is EDA. Here it is. If you click on that download button, I hope it is going to download. I believe so. Quickly, I'm going to share a link of downloading this particular software in the chat window. I mean, in Google Meet, I have already shared, and also with respect to YouTube chat link, I already shared with that. Please check with that. There is a link which helps you to download Is the Eda. So downloading Is the Eda tool. Of course, based on your computer, you have to download whether it is a Windows PC you are using or a Linux based or Mac. If you are using a Apple product or something, then probably you have to download a Mac version. But if you are using a Windows version, again, you have to check with a 32-bit or a 64-bit. If you are using a 64-bit, then please download the corresponding software. Okay. After that, installing process is also very simple. There is nothing necessary from my side to instruct you to install the PS circuit. I mean, install the software. So just don't worry about it. Try to install it by yourself. No necessary that we need to show that procedure to you. Pushpak is already downloaded with this. He is asking, sir, next step, sir. I already downloaded. Go for next step. Wait, man, wait. There are so many people yet to download with that. So once you completed with the download, type downloaded in the chat box. That helps me to get to know how many of you are downloaded and how when to start with the next procedure. If you're done with the downloading, please put a downloaded in the chat box. Yeah, downloaded. Just type a downloaded. That's enough for me. 4 of them are done. What about others? I think in YouTube also, I just wanted to go back and check. Let me refresh once again. I'm very scared about this, whether YouTube is having responsiveness or not. Well, yeah, it's updated. No worries. It's quite simple. No worries. What about others? What about others? Come on, guys. Completely, I mean, download it fast and try to install it. There is nothing special with respect to that. It is quite simple one. So try to install it without waiting for my instruction to try installing it. Try to install it. It's quite simple, in fact. Was the run mode setting, sir? What's the run mode setting? Nothing with the run mode setting. I mean, just go with the admin access, give it admin access and try to oh, okay. You are asking about run mode. I think you can use it as a personal project rather than teamwork. Go with a personal project. Let me try if I have that software. Let me try and let me try installing it as well, if it is possible. By the way, where is software? Here it is. EasyEDA. EasyEDA. Oh damn! I don't have EasyEDA at the backend. No, I don't have EasyEDA in my computer right now because it is already installed, because of which I have not kept a downloaded session. Somebody is sharing a screen. Guys, please stop sharing a screen. Please. Please. Rekha, please turn off your mic. And also, I think screen sharing is from somebody else, I believe. Not sure. I'm also not sure, but it is from other side. Please be muted. Whenever it is required, please talk to me. Otherwise, don't talk. I think Mariel, also you have turned on your mic. If you want to talk to me anything, please go ahead and talk to me directly. Wonderful. How many of you have downloaded? Only few people. What about others? Come on, guys. Start downloading it. Link not coming? Hey, link already shared with you guys. Oh my God. Wait. How come? Here is the link, I believe. I shared link twice in the YouTube chat section. Please check with that. I hope it's already visible, downloaded. So Varsha is saying downloaded in the YouTube chat section. So I believe everybody is able to download it along with her. Go ahead and try to download it very quickly. There is nothing much to worry about it. Just a second, guys. Well, I'm back now. I think it's just a minute. Well, there is nothing much to worry. There's how about my audio, guys? I just wanted to ask you people, is it my audio is clear? Audio and video part. Am I audible and am I clear with audio? Okay, okay. Danush, don't share your screen, guys. Please don't share your screen. Don't hit that sharing screen button, please, please, please. It will disturb my screen sharing process. That's why. Or skip it. Yes, of course, you have to register. I mean, I'll come back to that point. Just a few seconds. Danush, please stop sharing the screen. Danush HH. Admin, can you please control the screen presentation? I think Ravi sir or maybe Anusha madam. I think you guys are having control.
Yes, sir, we will do it.
Yeah. Yeah. Wonderful. Great. I'm like, oh, why I'm not able to? Okay, now I'm able to do it. Okay, so my audio is clear to everyone, right? I hope that is the one thing, because my teammates are saying my audio is not so clear. That's why I'm asking. I don't want to waste time sounding like a robot. Yeah, okay, that's a great thing. If it is clear, that's amazing. Wonderful. I believe everybody has downloaded. Okay, there are so many questions in the YouTube. How to download? There is a link actually. Is it? Okay. No worries. YouTube people who are watching from YouTube, you can go to Google and you can type Easy EDA download, and you will get a small window, like a small website like easyeda.com. In that .com website, you can click on the download button. It will go to one more page where you can choose which kind of a download you want to do, whether with respect to Windows, with respect to Linux, or with respect to Mac. So you can select any one of them according to your particular PC or the computer that you're using, and based on that, you can download. It's quite simple. I need not to share a link with you guys. Try to do it in Google directly. Don't expect a link. Try to do it in Google directly. All right, so now once you are done with downloading the software, let me share my screen and how it looks like. Before that, let me close something. Bro, no, not possible. I have to open this, I believe. Not necessary. Let me close it. Great. There are so many tabs at the back end. It is very difficult for us to manage, right? Hold on, here it is. When you download this particular software, this is how it looks like usually. Let me close everything. Yep. So this is how it looks like. Of course, you don't have any project in your directory because you just downloaded and you are a fresh user. So there are two icons at this particular center. I mean, at the right top corner, you can see login and register. Click on the register and register yourself by using a Google login, or maybe creating your own ID like username and password. Anything is fine. Don't worry about anything. You just create your account by using any one of your Google account, and you can start using it. That's it. So try to click on the register part and register yourself and try to create your account and come back to this particular login page. This is a page, or this is a UI, how it looks after logged in. Are you guys at this particular stage? Type logged in comment section if you are done with logging in after creating your account and all. Type logged in. Okay, a couple of them are already registered. That's amazing. Do it fast. Do it fast. It is not necessary to spend too much of time on this. It's quite simple. Do it fast. Okay, downloaded. Okay, now in the YouTube, people are saying downloaded for this. That's amazing. Oh, that's the problem. In YouTube, maybe we hosted our YouTube channel on Ravi Kumar sir ID, right? Maybe in that YouTube there is a setting participants cannot send the link actually. That's how it is protected from spamming other people in the group and all. So because of that, whatever link I'm sharing, you people are not getting in the YouTube. I think Ravi Kumar sir has shared link along with me. I mean, after my message and all, I guess you people are able to access that particular link right now. Okay. Wonderful. If you are done with the logging with creating account, registration, and all those things, please type logged in the chat box. Where to register? Of course, in the software. When you install the software, you can see the UI like how I am seeing right now. You can see my screen right now. I am presenting something in Google Meet, and I believe it is also reflected in the YouTube, and that particular screen will come to you. On the top right corner, you can see that there is my ID is looking to you. My profile is looking, Vaibhav Sugandhi. In the same place, you will get a login and register option. So click on the register, create your account, register to it, and log into it very quickly. It's just a 2-step process, I believe, 2 to 3 step. Wonderful. Varsha completed with the logging in. That's a great thing. What about others? Come on, guys, do it fast. Do it fast. Theory part is kind of a monologue where I used to speak a lot and I used to present a lot. I used to talk to you a lot. But right now it is a time to make you people talk to me. So make sure that complete it. Wonderful. 4 of them are completed. What about others? What about other people who are watching on YouTube? Come on. Do it fast, guys. Do it fast. It's already, we are done with the time. It is 12:55, 1 o'clock. So please do it fast. There are so many things to be discussed yet. Amazing. Logged in. I'll give another say 3 minutes to you. Okay, another 3 minutes for completing. And 3 minutes, not 4 minutes. Don't consider this thumbnail. This one only 3 minutes to complete your logging. Do it fast. Kaveri, as I already said, logging will look like on the top right corner. And on the top right corner in my screen, you can see that there is my profile here actually, right? Can you see this one? So in that place, you can see 2 options. One is login, another one is register. Click on the register for the first time because you are doing it for the first time. Tomorrow, you are going to click on the login part, but right now you have to click on the register part and register yourself. There are very few steps related to that. Nothing, there is 2 steps actually, that's why. Okay, so I hope now you guys can see this profile here, right? So my profile is here. I hope my screen is visible to you, and I believe you guys are able to see my profile at the top right corner where my cursor is hovering, right? So that is the place where you'll get to see login and register place, buttons. Do it quick. Do it quick. Another 1 minute last for everyone. Sir, my Mac is not supported to do register. Oh my God, Venkatesh, you are using a Mac and it is not supported. I hope you have downloaded the Mac version of the software. If it is still not supported, don't worry. Go to the website and create account in the website itself. It is also possible to use a virtual terminal. We can use it as a virtual software. Need not to download and install in your computer if it is not possible. It is always recommended to have a software in your computer, but if it is not possible, then you can use it as a browser version. So for example, I'll just check with that. In my case, it's quite simple, I believe. Yes, of course. If you go to the home page of the website, which is easyeda.com, just easyeda.com, you can see that on the top right corner, you can see that login and register available. Click on the register and create your account and register to that. Thereafter, it will ask you to go to the editor window, and then you can go to that editor window, which looks absolutely same as the local software client version of the software, but highly recommended offline after this particular tutorial or after this particular session, you try to install the software in your computer and try to create account in that. Okay, I'm very sure it is possible in Mac, but still try with that. Wonderful. So let me not spend much time on waiting for you guys to create account and login. I hope you're going to do it here and after, and I'm believing you guys are done with that. Okay. So in our YouTube channel also, you can see that so many people are already having downloaded that, I believe, but not done with maybe installing or logging in. I think it's quite easy. You guys can carry out with that, not an issue. Now let me start with my PPT, which is again important one. I need to refresh it. Okay. Here it is. It comes. Voila. Yeah. Great. So now I think you guys can see my screen with a presentation, which is a PPT in front of you. Now we are completed with the basic terminologies of the PCB industry and a designing tool. Now creating account in Is the Eda is as simple as I already discussed with you. Downloading it and creating account is as simple. As I already said, this is a home page of our website, and I mean Is the Eda Tool website. You just need to click on this icon here, which you can see, and you can create your account over there. Okay, you can use it as a virtual tool as well, and you can download it as a client version. It is left to you, whichever you want to do, you can do it. This is how the UI looks like. Okay. I think let me make a small modification in the tutorial today. I mean, a little bit modification with respect to the workshop for day one. Why? Because we are already running out of time. So I just wanted to say you one thing. We will make sure that we'll introduce the tool to you right now. I'll take another 20 minutes extra here, and I'll make sure that you guys are you are given with the introduction of this entire tool today. Tomorrow morning onwards, we'll start creating the PCB. We'll start creating the schematic and start working on the designing circuit and all those things. Entire day tomorrow, I mean, not entire day, entire 2 hours of tomorrow is going to be utilized for developing schematic and layout. Okay, because of time constraint, I'm having a little modification here. I hope you guys are comfortable with this. Right now, without wasting your time, let me introduce you how exactly this tool is all about and how it looks like. First of all, once you click on this particular login account on the top left side, top right side, not on the left side, top right side, you can see your account here. In my case, it is Vaibhav Sugandhi, which is my email ID and my login credentials. So you can see that Vaibhav Sugandhi is reflecting here. Thereafter, you can see that there is a project window on the left side of the entire screen, where you can see your company names can be visible if you create a group of each project. In your case, I don't think so there is anything visible to you because you have started using the Is the Eda tool just now. So you don't expect anything like this in your case. All the project you are going to develop is visible to you within this particular segment only. And there are 2 tabs within that. One tab is all about your project tab. You can see here, I'm extending it a little bit. One is an open project, which you are working right now. After completing the project, if you click on them and if you close them, not delete them, if you close them, then it will go and sit in the backend. And this is a backend where you can see all your project. In my case, with my 4 different account, not 4 account, 3 account. One is my personal account, which is Vaibhav Sugandhi. personal folder, not account actually. This is entirely my personal account, but within which Vaibhav Sugandhi is a personal folder. In that I have created a several project, practice project and all those things. In UTD folder, I have created a lot of account. As I already said, we have 3 companies. So UTD company account is already there. And then with respect to ERTKey, we have several projects completed. But altogether, with respect to Is the Eda, since 2.5 years, I'm using this Is the Eda tool. Previously, I used to use a Proteus and Eagle software, but recently I shifted to Is the Eda tool. Altogether, you can see that I have completed 131 projects. 131 projects. With that experience, I'm trying to explain you. So don't try to expect too much in your first attempt. If PCB is looking a little bit odd, if circuit is looking a little bit odd, if it is not satisfying you, don't worry. It is a time that helps you to learn that particular skill. Don't expect the the detail to attention to details that I am trying to give. In your case, it doesn't possible in just a 2 days workshop. Okay, but what is possible is you can learn the protocol. You can understand the process. You can understand the protocol in which I'm designing the entire PCB. If you understand that protocol, you can create your PCBs again and again as many times as you want. Okay, so remember those motivation factor, why we need to learn PCB, how we need to create a PCB, and why it is important in this particular digital era. Okay, so keeping that in mind, you can decide whether you want to go with designing multiple PCBs without giving any assignments, or you want to try with only those particular assignments, okay, which are given in this particular workshop. So this is all about with respect to project library. Then you can see the local library here. There is something called EELib, which is a local library where you can find the basic symbols and basic components like resistors and potentiometers, or you can say capacitors, inductors, or you can say connectors, or maybe a cell, or the battery symbol and all. Then some kind of terminals or connectors, and then headers and D-type connectors, DB9 connectors. All these kind of connectors, push button, LED, these are basic components or basic electronic component, right? So because of that, because of these are basic components, they are available in EELib category. Okay, they are available in EELib category. When you go to global library, if you want to, somebody turned on their mic. Is there anything you wanted to discuss with me? Do you have any question? All right, so if it is just by mistake, then no worries. All right, so where was in okay, in Is the Eda, right? So where is Is the Eda? Okay, so EELib is all about a local component, a very basic component which are used for basic circuitry design and all those things. But if you want to use some special component, special IC which is not generally used, but in your design you want to use it, on that time you can click on library and you can literally search for that component. And this component or this particular library is a global library. Everyone can access everybody's component. Say for in my example, you can type this specific number VEML 6040. If you type this particular number on the search window, VEML 6040, and if you hit enter, you can see that my library is visible to you in your computer. If you want, you can give a try on this. Give a try on this. Can you see my library in your computer? Can you see my library in the global library section? Can you guys do this activity? Are you able to do this one? No? Why not possible? Of course, you have to go to this user contributor section. Click on this user contributor section, then only you can see my name here. Owner name is available now. There you can see my name. If you type this specific number, VEML 6040. Do not do any typos and then expect my name in that particular library. It's not possible. Can you see my name, guys, in your laptop, in your computer, in your user interface? Possible? Yes or no? Possible or no? Give me a response. Am I audible, by the way? Oh, I little bit strange. I mean, it looks a little bit difficult for me to understand. My screen is not responding. What happened? Just a second. That's a bad thing actually. Whatever I have explained so far, it is all gone wrong, I believe. Oh my god. Oh my god. Oh my god. Sorry. So I think now it is visible to you everyone, right? Can you see the movement actually? I'm just scrolling down, scrolling up in email. Can you guys able to see that? Yeah, that's why I inform you guys, try to interact with me. If you are not able to see any movement in the screen, try to inform me early. That helps me to reduce my effort to explain you once again. However, no worries. This is E-lib factor where you can see all these basic components, as I already said. This is a library, which you can see a global library. In that case, if you click on this, there is a search window on the top side. If you type a VEML6040 and hit enter and go to the user contributed section, you can see my name on that particular section, where you can see my library, which is created by me, which looks like this, similar to like this. VEML, and Viber Sugambi, Vaishya Semiconductor, RGB, W, color sensor, something like that. In contributor section, in your case. In my case, it is a workspace because it is created in my workspace. That's why. Are you able to see this one, guys?
Yes, sir.
That's amazing. That's amazing. What about others? Only few people are interacting with me. When matter becomes serious, then very few people are able to catch it. What about others? What about others? Come on. Wonderful. 2 of them are saying yes for that. Amazing. Amazing. That's how you can access my library in your computer. That's what I wanted to show it to you. That's why I created this example. Okay. So this is how the global library is accessed. After that, these things are no useful to you, so just don't worry about that. So this is a project section, local library, global library. That's it. Okay. So now I will just try to create one small project for you, and I will leave that particular thing for today. Tomorrow we are going to create a schematic and then going to create a Layer Pcb layout. So when you click on this file option on the top side, you can see here, when you click on file option, I hope my screen is visible to you and it is interactive. Is it so?
Yes, sir.
Yes, sir. Yes, sir.
Wonderful. Great. In the file section, you can see that there is something called a new option. When you hover your mouse on the new section, you can see that there is something called a project. Sorry for that. So when you click on the project section, you can see a small interface here with your name as a folder. As I already said, I have 3 folders. One is my personal folder, another one is UTD company folder, another one is my another company folder, that is E&CE Innovation. So right now I'll keep my project in a personal folder. So in your case, it is only visible with your personal folder. You cannot see multiple folders because you have not created. Okay. So right now, this is all about my personal folder. In your case is also personal folder, and then give the name as a title, give that as a power supply, or maybe plus 5 volt power supply. Plus 5 volt power supply. And this path, whatever it is automatically created, don't change it, leave it as it is. And description section, it is helpful if you give a description, but it is optional. In my case, for your understanding, since it is the first project, I would like to give a description as plus 5 volt DC power supply using 7805, right? 7805 IC. Okay, you give a short description. Once you're done with giving a small description, you can click on save. The moment when you click on save, you can see a new window in front of you. Of course, as I already said, it will be visible within your new project. Of course, my new project is within my folder. So here you can see that plus 5 volt power supply is created. Okay, this is how the project is created. Now this window is visible to you. Keep that window as it is. Just hit Control S. You can see that sheet 1 is visible to you. Once you are able to see the sheet 1 and sheet is visible to you, keep it as it is. We will work on this from tomorrow onwards. There are several procedures involved in this process. Okay, there are several procedures. I highly recommend you to come up with a note. Actually, if you come up with a book and pen and paper, then probably you can note down how exactly it is flowing. Of course, there is a recording going on, but do remember it is quite difficult to watch a recording once again completely. Instead of that, if you note down the procedure, then whenever you know forgot something, you can look into your writings and you can get back to that mode very easily. That's why I'm recommending you to come up with a pen and paper tomorrow. But today we are going to wind up this particular thing here itself. Are you guys able to arrive at this particular stage? How many of you are able to arrive at this particular stage? This quite is similar AutoCAD electrical. Yes, Pushpak, this is quite similar to AutoCAD electrical, but little bit different. Again, this is also CAD software, one or other way, not directly. So how many of you are able to arrive at this particular stage, saving your project? I can see 1, 2, 3, 4, 5. What about others? 6. Sagar raised hand. Why Sagar? Do you have any question? Amazing. I can see most of. Sagar, give me a few minutes. I'll just finish certain things and I'll come to the question and answer section. Manjunath is saying you are in office mode for the software. Not recommended, Manjunath. It is better to change your office mode to teamwork. Not teamwork, I think student mode or general mode, I think. Check with that. I mean, it is not recommended. There are some limitation on office mode until and unless you purchase the software. So think on that. If you're on offline, okay, it is not office actually, it is offline, right? So if it is offline, I think it doesn't work, it doesn't respond to you. Make sure that you are on the online mode. Actually, you connect your internet to that particular software. I mean, connect internet to your computer and it will go back to online mode. Wonderful. I can see most of you are able to arrive at the stage where you can create a schematic sheet and create a project and leave it there itself. Okay, so lot of people in the YouTube also saying that they are also arrived. Not a lot of them. I mean, 2 of them said that. So they are saying they are also able to see that particular thing. But Gmail is not working. Oh, okay, not showing. Okay. Try to refresh the page. Try to refresh the entire software. It can be done by going to this top side and refreshing it. I just here it is, right? In this tab is there now, the big tab, Is the Eda logo tab is there. There, just you right click on the mouse, you can see there is something called a reload option. Click on that reload option. I hope your login will be visible to you. And it requires a good amount of internet. So I think you have to give a proper internet connection to your computer. Okay. Great. I can see a lot of people are saying they are arrived at the stage where I am right now. That's a great thing. Even in WhatsApp, not WhatsApp, even in YouTube, so many of you are saying they arrived at the stage where we are right now. That's a great thing. Wonderful, guys. Wonderful. I'm done with the day one. I'm done with the important part of the day one. I have achieved everything that is required for day one. Unfortunately, we are not able to create a schematic for today because of time constraint. That's okay. I believe tomorrow we are going to spend a lot of time on creating a schematic and then spending a lot of time on creating a layout and then working on a Q&A session and a further discussion. But right now, today, as per the discussion we had done, with respect to basics of PCB industry and all those things. Do you have any questions? Do let me know. I'm going to take a question for another 10 minutes and we are going to wind up the session. I hope, Ravi sir, this is what I planned. And do you have anything else to suggest me? Please go ahead. Ravi sir and Anusha madam, if you have any other plan for today.
No, sir, we don't have any plan, sir. It's a
Okay.
informative session, sir, for students, for the beginner only.
Yeah,
Students are facing some challenges not to install that software, so that is a main. That's why some students are struggling.
No problem, no problem. I mean, guys, it takes time actually. Don't worry if you are not able to install this software. Don't worry. You just check with the online process or check with some YouTube videos which are very simple, interactive videos where you can get to know how to install E&CE in your computer. There are several resources on that. But personally, I believe this software is quite easy to install and it doesn't need any much struggle. For the first time, of course, you feel a little bit uncomfortable, but that's okay. Being uncomfy is something that helps you to ensure that you're learning something new. Okay. Having said that, if you guys are having any question with respect to basic terminologies we discussed or basic definitions we have spoke so far, or maybe the theory part which I covered today, if you have any questions with respect to that, do let me know. I'm open for question now. You have 10 minutes for that. Even for YouTube people also, if you have any questions, I'm open for your answer in YouTube as well.
Excuse me, sir.
Yes.
Sir, this PCB designing has some limitations right now, sir. For example, thermal shock, and we can't make changes again and again in the motherboard. For that, instead of this, we can use wire wrap and point-to-point construction and extra. What if we can design a motherboard that can make update according to the conditions?
That's what I explained you, Manjunath, in the previous part of the story. I mean, the beginning of the entire workshop, I said, right, you can accommodate 2 or 3 updates in one PCB. Say, for example, if this is a PCB and it has a one connector, which connector goes for one particular module. Instead of that, you can make a 2 connector over there. And if you are using this PCB for one application, then you can connect one connector like this. And if you're using the same PCB for another update or another particular project which needs a different connection, you can do it. But can you accommodate more than 2 connectors, or can you accommodate more than 2 updates in the single PCB? It's not possible. It's just not possible. Why? Because you don't know what is the update is all about. You are asking something like, we have a motherboard inside our laptop. Go ahead.
I'm just asking that, can we make the designs that can alter according to the situation, sir?
That's what, it is not possible. That's what my answer is all about. I'm giving you why it is not possible. It is not possible. Why? Because see, in our motherboard, I mean, in our computer, we have a motherboard, right? And that motherboard is designed with one specific processor. It may be i7, Intel i5 or Intel i7 or something like that. You are expecting a Mac A10 is also coming and sitting on the same motherboard. And you are expecting Gibronix motherboard is also having the same socket where I can put a Mac motherboard or a Mac processor.
Not like that, sir. In order to that, I am saying that, what if I can make a processor into the whole system and integrate to the whole design and make it as a changeable or alternatable?
Not possible. Not possible. That's what I'm saying. Not possible. Even if you go with the i5 controller, i5 processor, if you want to change it to i7 processor, the same motherboard, you want to upgrade to the i7 processor, it is not possible. Why? Because the pin diagram of the i5 processor is different and i7 processor is different. And the speed at which it works is different. According to the speed, the tracks are drawn is going to be different. And current consumption is going to be different. Based on the current consumption, we discuss something called the track width, right? Track width is directly proportional to the current amount of current flows in that particular path. So for i5 processor, it is 1 mm track. For i7 processor, it is going to be a 0.5 mm. How you are going to match that? It's not possible, right? So that's why it is clearly not possible to create a one PCB for multiple upgrades. You can make it for at least 1 or 2 upgrades with a lot of talented work and a lot of congested design and all those things, but not possible to make it all in one design. Like I1 to i7, I1 to i10, I'm going to make it only one PCB. Not possible.
And the last thing, this generates some chemical issues, like, no, sir. Chemical after this region. Chemicals harmful which affect PCB, which motherboard which is designed from this PCB design.
There is no hazardous effect actually. No, that's what I'm saying. There is no hazardous effect on PCB alone. because it is ultimately a copper. But the component which we are using upon them, there is IC on this, right? This IC is a e-waste. If it is not working, if this PCB is not working, if it is broken or if it is damaged or something, then this PCB is a e-waste, electronic waste. And this IC may cause some hazardous effect to the environment, but not as a PCB whole. So we have to take care of that. We have to take care of that. That's why, government is coming up with all this e-waste concept and all in the recent days. Great. So do we have any other question, guys? Quickly, we are already 23 minutes late. So please quickly let me know if you have any questions. By the way, just before, do you enjoy the process? Did you enjoy the entire tutorial? Did you enjoy today's session, whatever I had discussed? Can I expect you guys tomorrow as well? Because we know that most of the people are like joining just because it is a part of their curriculum. But I'm genuinely asking you guys, do you feel it is really enthusiastic to you people? I can see so many of you are saying enjoyable and enjoyed and enjoys. That's a great. What about others? That's amazing. That's amazing. You people are saying yes for that. That's a great thing to me. That's amazing. Amazing. Great. Wonderful. Amazing. It was really fun to do design stuff. That's true, Pushpak. Actually, if you are a designer by default, then you will understand what exactly the intensity or interest that builds up when you're designing a PCB for the first time. Great. Let me replace let me refresh in YouTube as well. If there is any comment, then let me check with that as well. Quickly, we'll finish our process. So if you are attending tomorrow also, it is going to be a very amazing thing, and it is going to be very attractive to every one of you. So I personally believe it is going to be very helpful for you. Having said that, I'm done for the day. I'm done for the first day of this particular workshop. Thank you so much for attending, and I'm done from my side. So if anything from your side, I'm ready to go ahead. So do you have anything else to discuss, or shall we close it?
Thank you, Vaibhav sir. Hello, I'm audible?
Yeah, you are audible, Anisha.
Yes, sir. Thank you, Vaibhav sir. And as per the introduction session is considered, it's very really informative, and hope that tomorrow's session will be more interesting, and also our participants will attend this with the same enthusiasm. And all the students are informed to attend the tomorrow session at the same time, and the feedback and attendance link will be shared with you. Thank you, sir.
Welcome.
Thank you, Vaibhav sir.
Welcome, sir. Welcome. So thank you everyone, and thank you Ravi sir and Anusha madam for hosting this particular event, and thank you for everyone who are attended today, and I expect you people to show up on tomorrow as well. See you again tomorrow with the new topics, and it is going to be even more interesting than today. Today is just a theory, but tomorrow is going to be a practical, so I'm very sure it is going to be much more better than this.
Sir, can you share your email ID for that student?
Sure, of course. Sure, of course.
Okay.
Yes, of course. In chat window, I'm posting it. If you guys are having any questions, you can contact me over this particular email ID. This is okay. This email ID, whichever I posted in our Google Meet chat window, and also in our YouTube chat window. I'm not sure whether it is visible to everyone or not, because it's again a link. So whether YouTube algorithm will help to know it or not, I'm not sure. But those who are interested to contact me after this workshop program, no problem. I'll give you all the contact details after this workshop tomorrow evening. But I mean, not tomorrow evening, tomorrow after the session, maybe at the 1 o'clock or something by the end of this entire workshop. But right now, if you have any doubts or anything to be contacted with me, you can contact me over that particular email ID, eartkey@gmail.com, EARTKEY@gmail.com. That's my professional email where you can contact me. But if you want my contact number also, please attend tomorrow's session. By the end of the entire workshop, I'm going to share my contact detail as well. Directly, you can contact me at any point of time, which I'm going to share tomorrow. Okay. See you again, guys. See you tomorrow. Bye-bye.
Thank you, sir. Thank you, and all.
Yeah.
Thank you, sir. Thank you.